In this video, we will be going through C++ from the very basic to the advanced for a beginner.
Today, I'm going to give you the overview of what you're going to learn and the very first lesson, that is starting off with C++. Now, this course will offer from basic to advanced. So if by chance, if you know nothing about coding, still you will be able to figure out what is happening and we'll go to the very advanced. The very first topic would be that how to run C++ code, or from where should we run the code? How should we write the code? So there are various ways to do that. If you have an online option, I can show you that as well. For example, there are certain websites, like for example, one is this one, where you can directly do the code. Just simply start create, choose the language. It's called as REPL-it. If you have never seen this website before, you just have to type this particular thing in the browser and you can simply use this simple website. If by chance you need an offline one, which is the better choice because you can simply download in your computer and you can simply use it anytime, even if you don't have internet. It's called as C-free. Simply type C-free and you can download from anywhere you feel like. It's a very wonderful software where you can do the coding. I have already downloaded it. We don't need any kind of internet in order to run the code. So we are starting off with C++, that is, we'll do the very first piece of code. And generally when we start any programming language, we start with the program Hello World. But the main problem is that even if I write the code of Hello World, you may not understand what is happening over here. So I'll go line by line, what exactly is happening. So when it comes to C++, the very first thing we give is a hashtag. Then we write include and we write iostream.h. Now, what does this particular line means is that we don't say hashtag in C++. It is called as a preprocessor directive. What does it mean? Is that we are including one library file into our program. The name of the library file is called iostream, and iostream, if I have to write the full form of it, it is called as input output stream. So generally, for example, if any kind of input or output kind of statement you're going to write in your program, we have to use this library file. Otherwise, it will not work. I will even show you with that with an example. After we have included a library file, we will write using namespace std. Now, this particular line is completely optional, but I would highly recommend you to give this. The reason also I will explain you as well. Next part, which is even more important, is the main function, which is called as int main. This is probably the most important line because that is the main function of the program. And one point you can note down here, if you're noting it down, that main function will be there in all C++ program, irrespective of what kind of program you're making, because main function runs the main statements of the code. Whatever you're writing inside it, that comes under the main function. Now, the very first program, as I said, that we're printing hello world, or you can print your name or anything like that. So what I'm going to write is we're going to write cout. The full form of cout would be console out. So C means console and out means output. And then we're going to give this bracket over here. And then we're going to give double quotes. And you can write anything inside it. Let me write hello C++ program. And we're going to give a semicolon. Now this semicolon is given in order to tell that this is the end of this particular line and you can terminate this line on this particular point. So after semicolon, if you write something, that will considered be as an error. So semicolon means that particular line has been ended over here. Now, one point you can note that semicolon is not given in every single line in C++. Like for example, you will not see a semicolon in the header file. This is called as the header file. And you will not find a semicolon in the main function. But other statements, mostly you're going to find a semicolon just to tell that this particular line has been terminated or end over here. Next thing we're going to write is return 0. Now, why do we give return 0? Now, it's a very important concept over here that when you write a main function or a simple function, if you learn in any programming language, its job is to return something. Now, if in our main function, we simply need to print this thing to our console. That's why I have written console out hello C++ program. So basically, when I'm going to run this code, this thing will print, but I don't need anything in return from this function. So I have said that when you are writing this particular code, here int is given. Whenever you have this integer thing, which is called as a data type, which we're going to learn in the future classes, data type of int always has to return something when it is used in a function. So since it's a main function, it should return something. But we don't have anything, or we don't want anything for this function to return to us. So I'm writing, you can return something, but return 0. That means don't return me anything indirectly. In some compilers, if by chance you don't give this, still it will work. But I would suggest you that you definitely have to give a return 0. It's a bit good practice for that. Now, if I run the code, there's so many ways to do it. I have a green color play button over here, or I can press the F5 in my keyboard. And as you can see that it has printed hello C++ program. It's very simple. And I can do different experiment with that. For example, we have certain things like if I give here a ENDL, that means end of the line. And I can run the code. It will be again the same thing, but this time the next line which comes, it will shift to the bottom line. So it is end of the line, means here the line has ended. You can carry on with the next line. That is what it means. Now over here, I did tell you this about using namespace std. What does it do? If by chance I don't give this, for example, I'm not using this particular thing. So what I have to do is I have to write a namespace in each and every line like this. If I run the code right now, it will run. So if by chance I don't write this, then it will be an issue. Some compilers may give us an error. So I can write std in this way in every single line, or the best way to do it is write this one time and you don't have to write it in the entire program anywhere else. So this will be if you have used namespace one time, that's it for the whole group. Now, if I have to give you a quick idea about what I did over here, first thing we did is including the header file, which is hashtag include iostream.h. Here hashtag is the preprocessor directive. Include means I'm including an header file. Name of the header file is iostream.h. What does iostream means? It is input output stream. So whenever you're doing any kind of input or output, like for example, we're doing on line number 7, that is we're outputting something. So iostream is required. Then we came to the using namespace, which is an optional thing. You can write it, which is a good practice so that you don't have to use it in any part of the program. You can just write it once using namespace. Then came the main function, which is the int main. Whenever you see int main, remember that it will return something. Then we have the cout, that is console out. And in the double quotes, we have written what we need to print or what we need to give as an output. Then we have the ENDL, which is end of the line. That means if a next statement, if we have to print or anything like that, it will come in the next line. If I don't give the ENDL, it will simply start from the same line itself. Then we have the return 0. Int main returns something, but here we don't have to return anything. So I'm telling the compiler that return 0 means you have to return, but return me 0. That means indirectly I'm saying don't return me anything, and I have stopped the code. Now, important thing here is that if you see, I have used curly brackets over here. Whenever the curly brackets start and whenever the curly bracket ends, that is called as the scope of that particular piece of code. So that means if by chance somebody asks you what is the scope of the cout, it is starting from here until here. So that is a basic starting of C++ and how you can print something. I hope you have understood some of the points which I have told you. If by chance you didn't get it, you can put down in the comment section so that I can reply you with the answer you need. Welcome back. Today we will learn about what does the word compiler means. In the previous video, I was talking a lot about the word compiler, but I didn't give you any idea about what is it. So it's very simple to understand is that, for example, if let's say you are having a class and in your class, you are giving a test. Now, let's say your test has 10 marks in total. Out of that, you're scoring around 7. What happened to the rest 3? It was a mistake, or maybe you was not able to write the answer. Consider them as mistake. Biggest question is, who will find these mistakes? Well, it will be found by your teacher. So basically, teacher's job is to find mistakes in the student's answer sheet. Similarly, compiler works in such a way that its job is to find errors or mistakes in a program. So compiler, what it do is, it will compile your code. That means it will check for errors, bugs, or anything like that. And it will show you the errors or any warnings. For example, if I didn't give this header file, then what will happen is if I run the F5 button over here, you can see at the bottom that I am getting certain errors and warnings. Like as you can see, the cout undeclared. That means it now doesn't know what cout means because I have not given the iostream.h. Don't get confused that it is still there, but why it is not working? Because we have given comment over here. Comment thing we will learn in detail in the coming classes. For now, you just understand that that thing is not there right now. And you can see that we are getting certain errors and warnings. The main issue which we are seeing is that cout undeclared. That means it is showing the error on line number 7, and which is true because cout won't work if you don't give the header file for cout. If I give it back and then run it again, you will see that it will work perfectly fine. As you can see, I have printed welcome back. So compiler's job, what it do is it simply compiles the whole program and then it will tell you whether it has error or not. If the compiler doesn't find any error or any warning, then it will simply gives like this, that as you can see here, 0 errors and 0 warnings. That means you're good to go. You can run your code and it will work perfectly fine. Now, there are other things also like different programming languages use. Like if I talk about, let's say Python. If you don't know Python, that is completely fine. But Python, what it does is don't use compilers. They have something else, which is called as an interpreter. But when it comes to C++, how a compiler works is it will read the whole piece of code at once and it will check for errors. Whereas in Python, what it will do is it goes line by line. That means it will read the first line to see if there is any error. If by chance Python program, there is an error on this particular point, let's say. So it will stop over here and it will not read the rest piece of code. So that is the basic difference between a compiler and an interpreter. When I will teach you Python, then I will talk about interpreter in much more detail. Right now you can understand compiler is that it is simply checks for any error or warning. If you want to learn compiler in a bit more advanced way, better way to understand compiler is that it also does is it simply translates your program from the human readable source to the machine language. For example, this thing which I have written over here is the way how we write or how we understand. But machine will not understand this piece of code. They have their own language. So for this, what we do is the compiler's job also is to translate this particular thing to the machine language so that the machine also understands. And then it will be easy for it to find errors or warnings. So I hope you have understood what a compiler means. If you have any doubt regarding a compiler, you can put down in the comment section. Welcome back. Today we will learn about two things, which is variables and comments. In the previous class, we have learned about compiler and how a compiler works and what does it do. Today we will see two topics, starting off with comments and then we'll move to variables. Now when it comes to comments, we all know that what exactly it do. Comments' job is to tell us that what exactly is happening. For example, you're watching this video and if you have any doubt, you will comment in the comment section. So you're referring to me that I'm having a problem over here, or you're trying to tell me that there is something on this. So basically comments are completely optional thing, but very, very important. Important in the sense that if I give you an example, imagine it like this, that you have a whole team of let's say 30 members and you're working on a gaming project. Let's say any game you're making, it can be a huge game or a small game. Now, all these 30 persons may have similar or different capabilities of what they're working on. Like for example, somebody will work on the functions of the game, somebody will work on the design of the game, somebody will work on the actions of that player, somebody will work on various different things. So now the point is that if by chance I'm writing a piece of code and my job is to explain that what exactly I have done over there. Like if I say that if a person knows how to do Python programming, he have no idea about C++. But Python and C++ are not that much of difference. Like if you know both the language, you will get the idea that yes, fine, this is what is happening over here. But when it gets very advanced, then it will be a little bit tricky to understand it that quickly. So we use the method of commenting in order to explain the other person that what exactly we have done over here. For example, I have written here int main. Now there is no concept of int main in Python. So we don't need any main function over there. So we will give a comment. How do we give a comment? We write two lines like this, two slashes like this, and then you can write that this is the main function. After the slash, whatever you write is completely ignored by the compiler. That means this thing is completely ignored. It will not affect the program, whether it is having an error or whether it doesn't have any error. So you can write as many lines or as many comments as possible. There is no problem with that. This kind of comment where you have like using this 2 dashes which we are giving, this is called as a single line comment. What does that mean? For example, I cannot continue this in the next line. That means if I write here that this thing won't be a comment because this line is only the comment. So you cannot come down in the next line. So it's a single line comment. You cannot use multiple line. Now for multiple line comment, we have another way of writing it. We give a slash, then we give a star, and then we can write here that today we are learning about variables and comments. As you can see, this is what we call as a multi-line comment. That means inside this thing, I can write as many things as possible. I just have to give a slash and a star, star and a slash. So it's very simple to understand comment, though it is optional, but very, very important because we definitely need to explain others that what exactly we are doing. Next up, we will come with variables. Extremely important topic in C++ as well, that what is a variable. Now when we have to learn about variables, it's very simple to understand it this way, that it is simply a location which is in your memory of the computer, which we give a name. So this can be a formal definition about what is a variable. So location in a memory which we give a name. If you want to understand it in a very, very simple way, you can understand it this way, that you can take a water bottle. The water bottle is the variable. The water inside it is the value. So we have given the name water bottle to it because we want to name it something. Then only we can get the value from it. So variables are simply a storage unit of a program. Now, variable in C++ has to be declared before we use. Now, what does this declaration mean? For example, for that, we have to write the type of data. I'm just giving an example over here. And I have to write the variable name, whatever name you can give. There are certain rules for that also. And then I can give a value to it. So this is generally how we write or declare a variable. If I need to give an example here, I can write here int number equal to 4. So this is one example where int is a data type, which we will do in the future classes. Number is the name of that variable and 4 is the value given inside the number. So you can understand it this way, that there is somewhere in your memory a variable called number has been made and it has 4 inside it. Now the point is that can we give any name to our variable? Well, that is not the case because there are certain rules in order to declare a variable. Like for example, the very first rule would be that variable cannot start with a number. Like for example, I cannot write here int 4 number equal to 1. If I run the code over here, you will see that you will get an error. Let me comment this particular line. Yeah. Now you can see we have an error on this line. So it has shown me that I cannot write a variable of this particular name, 4 number. So remember this point, that variable cannot be started with a number. Or you can more precisely say variable name cannot be started with a number. That is the very first rule. Second point would come is that variables are case sensitive. What does it mean? Well, when you talk about variables, if I write a variable, let's say int a equal to, let's say 4, and in the next line I'm writing int a equal to 4. Now they are different variables. They are not the same. Small a and capital A, they are both different. So they are case sensitive. So by chance, don't get confused between them, that they are completely different variables. Small a is a different variable, capital A is a different variable. So that is what we call as a case sensitive variable. So we have to be very careful when we write a name of a variable, because if in case we have given the n capital, next time we're giving the n small, then there will be a conflict. Third rule would be that variables cannot use any special symbols or characters. For example, if I write here, let's say %, percentage, number equal to 4. As you can see that it has shown me one error at the bottom, that I cannot use a special character when I'm writing a variable name. Moreover, you cannot give space while writing a variable name. For example, if I give a space over here and then I run the code, you will again see an error at the bottom. So space and special characters are not allowed when naming a variable. The last rule which comes to a variable that you cannot use any keyword while naming a variable. Now, since you have started learning C++, you may not know keywords, but let's say over here, if you see that int is changing color, return is changing color. So these are all keywords. So let's write int return equal to 4. If I run this piece of code over here, you will see that there is an error. I cannot use any special character when I'm naming a variable. So that is the fourth point. Now let me write certain variables. You tell me in the comment section that which one is correct and which one is wrong. Now I'm going to remove this and let me write certain variables. You tell me which one is correct. Now I have here a couple of variables which you can see, which are declared using certain data type, and I also have certain numbers. Now here I have declared and initialized both. Initialize and declaration means when I write only this, for example, if I'm writing in the previous line, if I write here int underscore a and give a semicolon, this is what we call as a declaration. But if I equal it to a number or something, a value, then it is called as declaration plus initialization. So now over here, if you see that underscore is not considered as a special character. So that means this thing is completely correct. Next, if you see, here we have an underscore, in between underscore a, no space, no rules are broke. This is also correct. I told that we cannot start a variable with a number, but we can definitely put a number in between or at the end. So that means this is also correct. Here you see that a variable is starting with a number. So that means this is wrong. Here if you see a special character has been used in the center. So that means this is also wrong. And lastly, all these are simple alphabets which we can use. So this is also correct. One may get confused that I told that if you use capital U, you cannot use small u. The reason was that if you use this variable, this one, and in the next line, let's say you write like this, equal to some other number, then what will happen is this is the problem. Now you see that I have changed this u to this u. So I have changed this. So this is violating the case sensitive rule, and this will be wrong. In one time when you declare one variable, whether it's capital or small, it doesn't really matter. So that is absolutely correct. Now we have even more advanced topics when it comes to variables. Like we have different points like local variables, instance variables, or static variables, which we will definitely do in the future, because for that you have to learn certain other points as well. Welcome back. Today we're going to learn about data types in C++. In the previous class, you have learned about what is variables and how we use comments. Today, we're going to discuss about data types and the types of data types. Moreover, I will even show you the practical implementation of that. Now, whenever we start learning any programming language, data types is a very, very important thing we have to know. Like it actually tells us that what kind of data you are using in the program. When it comes to C++, it is very important to understand each and every type which is present. That is, we have to know all those data types which are there. Now, when it comes to the definition of data type, in very simple words, you can say that data types are nothing but data a variable can hold. So it can be any kind of data, whether it's a number or maybe a decimal number or something else, which we will discuss later. But right now you can simply remember this 5 words, data a variable can hold. Or you can even add one more word in front, type of data a variable can hold. Now, when it comes to C++, we have 3 types of data types. The first one, it's called as primitive data types. Second one is called as derived data types. And the third one is called as abstract data types. So these 3 are the major data types which are present in C++. And you have to have a note that these are also subdivided into various data types, which we will discuss now. We'll start off with the very first one, which is the primitive data type. Now, when we talk about primitive data type. In simple words, you can get the idea about is that primitive data type are simply built in C++. So these are data types which are already there in C++, and we can simply use them in order for us to make work with the particular data. And in primitive data type, we have subdivided them into, first one is integer, then we have character. After that, we have Boolean. Then we have float. We have double. We have then void. And last, one more, which I will write here in the center. It is called as wide character. Now, if you see all these 7 kind of data type, which are all the primitive data types found in C++, extremely important and very, very useful. We'll start with the first one, which is integer, and I will give you the idea about how integer works. So when we talk about integer, very simple to understand. Integers are those data types which can hold number which are there in your number line. For example, all the integer values is kept in this data type. And we refer this using the int keyword, which is found in C++. That means the integer data type can carry all the integer type values inside it. But we have to know 2 things about integer, that it has a particular range. That means you cannot put more number than that or less number than that range. The range is -214 748 3648 to +214 748 3648. So this is the range of an integer data type. If you have made a variable using int keyword and you want to store a value, you have to remember this range. You cannot put less than this particular number, or you cannot put more than this particular number, because every data which you take takes a little bit of space in your memory. And for integer, we have 4 bytes of maximum memory. So you cannot go beyond that. For that, we have different kind of data types. The next one we have is character. In C++, we refer it as char. Characters are written inside single quotes. That means I can write something like this, that I can write char, which is a keyword, and then I can write a variable name. Let's say my variable name is a equal to, I can give a single quote, and let's write a capital A over here and give a semicolon. So this is initialization and declaration of a character variable. The important point which you have to remember of character is that character takes 1 byte of memory. The next one was Boolean, which in C++ we referred as bool, B-O-O-L. Now this is a very interesting kind of data type, because bool can give only 2 outcomes. That means you can get either true or false. For example, if I say that today after 7 p.m. it will be rainy. Now I've given a statement over here. Let's say you're watching this video at 2 p.m. in the afternoon, and I have given a statement that after 7 p.m. it will be rainy. Now, do you think whether the statement will come in the category of true or false? Nobody can 100% predict or say that it will be rainy after 7 p.m. Even if somebody have told you, or let's say you've seen the weather report that it will be rainy in the evening, it is not 110% sure that it will be raining after 7 p.m. So these kind of statement will definitely not come in the category of Boolean, because you cannot give or justify the answer to it. Statements which can be true is, for example, if you're, let's say, in grade 10 right now, or in grade 8 right now, you can say that after 1 year, I will be in grade 9. So this is going to be always true. Let's say one more statement is that I will take the umbrella if it is rainy or if it is very much sunny. So that statement also will be true. Those statements will come under the Boolean section. The next data type is float. or we say as floating point numbers. Floating point numbers. A float is a very interesting kind of data type because it holds all floating point numbers. Floating point number means all numbers which are having a decimal point. For example, 5.6, 7.8, 8.8, 9.1. Any number which has a decimal point are called as floating point numbers. How do we declare or initialize a floating point variable? It's very simple to do that. We first write the keyword, which is float. We will write it in small letters, float, and then we'll write a variable name. Let's say I'm writing num equal to, let's say, 4.5 and semicolon. So this is how we initialize and declare a floating point variable, where the name of the variable is num, and it has the value 4.5 inside it. Now, floating point also take 4 bytes in your memory. So that point also you have to remember. Then we have double. Now here you may get confused a bit because double is also a floating point number. So you're gonna ask, what will be the difference? Well, it's a very minor but a simpler difference is that double is simply more precise. What does that mean? For example, if I write a number 2.3 and in the next line I'm going to write a number 2.314821056781122. Now you tell me, which number do you feel is more precise? Obviously it's the second one. So this number will come in the category of double. This number will come in the category of float. Very simple to understand. Now since it has to take a very high precise value, double needs more memory. So that means we give it as 8 bytes of memory. And how do we define or how do we declare a double variable? We simply write the word double or the keyword, write a variable name. Let's say this is num1 and give a number, let's say 2.36812311. So this can be considered as a double variable, which is having the value of this. Next one is void. Now, void is a very uncommon kind of data type which you generally don't use, but void refers something to that has no word. Simply, you can say that it is empty. So if it is empty, why do we need it? What do we have to store it? Well, the void data type refers something which is valueless. In simple words, you can understand that a void kind of data type, it cannot be declared. We cannot declare a void kind of data type. It is only used when you will learn functions. And we use void in functions when the function does not return anything. If the function doesn't return anything, or we don't want the function to return anything, then we use the void. Next, we have the void character. Now, void character is also a little bit tricky and uncommon, and we refer it as w char underscore t. This is the keyword which we use for void character. Now, since it is also a character, you may think that it takes 1 byte of memory, but actually that's not the case. It takes 2 bytes, or sometimes in some compilers, it can take 4 bytes as well. The big question will come that why do we need this void character? Well, the simple answer is we need this when any character or characters need more memory than 1 byte. For 1 byte, that is one single character, we have the character data type. But when we need more, then we use the void character. How do we declare or initialize a void character? Well, it's pretty simple. We're going to write w char underscore t. Let's say a variable name. Let's write c equal to, we will write it, for example, a b. This is how we represent. So these are all the primitive data types present in C++. Now, after we have finished all the primitive data types, we have the other two types, which is derived and abstract, which we will not do today in detail because it will definitely come in the future classes. But I will show you the implementation of the other primitive data types which we have been used. Over here, I have mentioned all the data types which you have learned, and I have also given and initialized them to certain values. Now let's print them all one by one and see what they give as outcome. If I run this piece of code, you will see that I have got all the values which I have mentioned over here. So we can put different kind of values over here if you want. Since I have put these values, so you're getting the answers over here. But the point is that one thing you may notice over here, that the third one is printing 1. Even though the thing I have printed as true over here, it is not printing the word true over here. Well, the reason is simple. When you're talking in computers, we generally work with zeros and ones. So here you have to remember one thing, that 0 means false and 1 means true. So since I've given here true, that's why it is printing us the answer as 1, as you can see over here. So those are about primitive data types. There are other data types versions also, which we will learn in the future classes. Welcome back. In the previous session, we have discussed about what is data types and how do we use data types in our program, why it is so important, and what are the different types of data types present in C++. Today, we were doing is one very important topic which you can directly or indirectly relate with data types, which is called as operators. Now, operators is a very big and broad topic, so I will make separate videos on it so that you can understand each and every operator, the concepts and the clarity with examples of programming as well. Now, when we talk about operators, I'm pretty sure you have learned operators, even though whichever grade you study in, you've studied operators in mathematics. Well, it is kind of same, but here more operators are there in C++ when it comes to C++ programming. But some of the operators, like for example, today those operators which you're going to learn about are mostly related to maths only. So it's going to be a little bit easier for you if you don't have the background of operators in programming. Now, when it comes to operators, if you need a very formal definition, these are all operations which we do in C++. So to do any operations, it can be any kind of operations. We need the use of operators in the programming language, whether it is C++, C, or any other programming language. And C++ has a varieties of type of operators, like they are divided into certain different parts. For example, if I have to say that, generally in C++, we have 5 types of operators. And we'll discuss them in individual videos so that you don't get confused. I'm not going to discuss today in all the 5 types. So I'll just give you the basic idea about what is operators. And then from the next video, I'll give you the idea about what individual types of operators. The first one is called as arithmetic operators. Second one are assignment operators. The third one is comparison operators. Then we have the logical operators. And lastly, we have the bitwise operator. Now, these are the 5 types of operators which we will do in individual videos so that you get the idea about all these operators. Welcome back. In the previous class, we have discussed much about what are operators and how many types of operators are there in C++. Today, we'll do the very first one, which is the arithmetic operator. And if by chance you don't have any idea about programming, but you do have learned maths or mathematics in your schools, you're going to see pretty common operators which you have been used. And arithmetic operator is probably the most easiest one to understand because you can relate it to maths directly. So when it comes to arithmetic operators, all those common mathematical operations which we do using the arithmetic operators. For example, the very first one is plus or addition. So in simply the addition which we do in maths, like for example 1 plus 2, 3 plus 4, common thing like that. Here in programming, we just change it to adding variables, and variables can have different values, and you can give any other values to it. For example, I have to make if I have to make 2 variables, for example, a is equal to 1, b is equal to 2, you should know what will be the answer that will be stored in the sum. So sum will be, if I print the sum, it will be 3. So it's very simple to understand arithmetic operators. The first one is plus. Second one would be subtraction or minus. I'm pretty sure you can relate now. The third one would be multiplication, multiply. Fourth one will be division. Fifth one is modulus. Now this maybe somebody will get confused, like what is it if you don't know it. Let me tell you or give you the idea about it. Modulus we write using the percentage symbol. Now what does modulus do is basically is that it's very simple to understand. Let's say if you have a number, if I have 10 and one number I have 5. If I ask you that if I divide 10 divided by 5, can you tell me the answer? Obviously you can. The answer will be 2. So what does modulus do is, modulus job is to give me the remainder of a division. That means it will directly give me the remainder of any division. For example, if I have, let's say, 217 divided by 18, for example. Now I'm going to divide it as normally we do, 217 divided by 18. So 18 ones are 18, 37, 18 twos are 36, remainder will be 1. So if I do like this, that 217 modulus of 18, it should directly give me the answer 1, because that's what the remainder is. So you can get the remainder of any two divisions using the mod. If I give you one more example, if I write here 625 mod 25, I know this answer will be 0 because 625 is completely divisible by 25, because 25 into 25 we get 625. So like that. So you will directly get the remainder of a number using mod. Now there are two more operators which we call as increment and decrement operator. This one are a little bit complicated because we don't generally see it in maths. So this one we will do in the next video. Welcome back. In the previous class, we have discussed about operators. That is the very first category of operators, which is the arithmetic operators. And I have made a very simple program in order to see how arithmetic operators perform. I've taken example of only addition over here. You can put any symbols here. You just have to change this operator symbol. The program will change. If I run this piece of code, you can see that it should give me any random number. The reason it is giving a random number is this, you will learn in future classes that this is called as a garbage value, because I have not initialized any number to it. For example, if I initialize a number here, let's say if I give here 34 and the next number I give as 11. So if I run this code now, you're going to see the answer is 45. So it's very simple to do this kind of arithmetic operators. You just have to simply add them. Now today's class is very, very important because today we're going to discuss about what is increment and decrement operators. And it's very easy to understand, but for the very first time, you may get a bit of confused, but if you listen to it very carefully, that you will understand it at the point. First, we'll discuss about increment, then we'll move to decrement. From the word only, you may get the idea about that. What increment means, it is increasing in simple words. Now, when you use the word increment in programming, it simply means I'm incrementing by 1. It can be any other number also, but by default, you may think that I'm increasing by 1. Any number, any value, any variable. What exactly it means is, for example, if I have a variable a and it has any value, for example, I have to increase this value or increment this value by 1. So how we'll write it? I will write as a plus 1. But for programming perspective, we have changed this and we have made this thing a bit more stylish to look it like this, that we can even write it as a plus plus. Whenever you see a plus plus, understand that a has been incremented by 1. That is what it means. Now, if I give an example, if a was 5, if I write a plus plus, a should change to 6. Very simple. Now, increasing can happen in two ways. Okay, it comes with both increment and decrement operators. There are two types. One we have a prefix and one we have a postfix. Now, right now you won't see much of a difference. The only difference is of the writing way. That means prefix we write as plus plus a, postfix we write as a plus plus. And if you consider an example, if a was 5 here also a will become 6. Here also a will become 6. There's no difference right now as it sits. Okay, this will also become 6. But the fact it will change is that if I write here in the next line that if I write y equal to plus plus a and y equal to a plus plus, then if I ask you what will be the value of a and what will be the value of y in both the cases, then it will be a little bit different. Think of it like this, that it's very easy to understand. If you see here, whenever you see a plus plus or plus plus a, we know that in the previous only we have studied that a will increase for sure. Okay, there is no like difference in the a. So if plus plus a and a plus plus is there, or any other variable could be, a will be increased. For example, here if a was 11, so a will become 12 in both the cases. There is no difference in that. A will become 12 in both the cases. The difference will come with y. Okay, see here what exactly happened. Now this may be a little bit confusion. See very carefully. See here, how to understand this is that y is equal to plus plus a. Now what is y directly equal to? It is equal to this plus plus signs. That means y will increase and then a will increase. So that means a has 11, a increased, it became 12. This 12 will go inside the y. So y will also become 12. I will repeat it one more time. You have to see y or the variable is equal to the plus plus symbol. This way you can understand. So if the plus plus symbol is coming first, that means whatever value a has, if it is increasing by 1 or any value, this y will also increase by that value itself. So if a was 11, a will become 12 and y will also become 12. But here the case is different. Here if you see, y is equal to a. So when this equation will be run by the compiler, or it will be executed by the compiler, y will be directly equate to a. So what was a? A was 11. So y will remain 11 because this is postfix. It is adding, or the a is incrementing after it has equated. So y equal to a, that means y will be 11. Then a will increase, then a will become 12. Same goes with decrement operator also. I will show you this with a program itself. So if you see here, I have made a simple program in order to explain you how this thing works. First, I have made 4 variables, x, a, y, b. X has 10, y has 18, and a and b are 2 different empty variables. Now we are doing pre-increment operations and then post-increment operations. Now pre-increment operators, if you see here, let's say we have a and then we have x. Now, if I talk about a slide, I have shown you that a is directly equal to this plus plus. So that means if x will increase, a will also increase. So x, I know that the value will be increased. So x was 10, it will become 11. Now a is equal to this plus plus x. That means x has become 11. So a will also become 11. Fine. Now once this has been done, once a has increased, now the 11 will be loaded to a. The 11 value will be gone to the variable a, and the x value will be gone to the variable x itself, because x is incrementing. So it will be also increased. But here the case will be different. If you see here, b equal to y plus plus. So here what will happen is, first and foremost, y will increase. We know that. So what was the value of y? It is 18. So y will definitely become 19. No doubt about that. But when it comes to b, if you see b is equal to this y, so b will remain what value it has. So it will be 18 itself. That means it should be printing here that it should be 11 over here. And then x obviously will be 11 itself. Then b will become 18 because this is prefix, and y should be 19. So we should get as 11, 11, 18, 19. If I run the code, if you see here, so as you can see, 11, 11, 18 and 19. It may be a little bit confusing. You watch this video from the starting one more time. See if you understood it. If you don't understand, you can comment down in the comment section. I will explain you one more time. Welcome back. Today we are learning about assignment operators. What is assignment operators and how do we use it in a program in C++? Everything I'm going to tell you from the very basic. Now, assignment operators generally we use to assign something to the variables. For example, if I write here a equal to 1. So that means imagine this a is a variable and I'm assigning a value to it, which is 1 over here. I can write maybe something else, let's say b equal to 3. So this is a variable where I'm assigning the value 3. So that means this 3 is going inside this b. So by this you can understand that this equal to sign is a type of an assignment operator. So we are assigning something to a variable. Similarly, we have different kinds of assignment operator in C++. So let me write all the assignment operators so that you can get the idea about it. The first one you have already seen it, which is the equal to sign, by which we can assign something like, for example, a variable to a value. Then we have the additional assignment operator. Now what is this? This is something new. If I write like this, for example, if int x equal to 10, and the next line I'm writing here is that x plus equal to 5. So what does it mean? That this thing I can write as x equal to x plus 5. So this thing I'm writing in a much more shorter manner, or generally it is writing this way in a C++ program. That means whatever x has, I will equate it to the x plus 5. That means our x had 10, here 10 will come 10 plus 5. Now this will become 15 and 15 will replace the value of what it was. So now x has 15. So before x was 10, we have made it to 15. So that is the logic. Similarly, we could use the same thing for subtraction, multiplication, division, modulus, exponent. Now there are others also, like for example, we have a not equal to sign, which is like this. Like for example, if I have to compare, like let's say if I write 5 not equal to 6, this statement, if I use the boolean, this will come as true because 5 is not equal to 6. If I write 5 is equal to 5 and this I do with boolean, this will also be true because yes, 5 is equal to 5. If I do 5 is not equal to 5, then this statement will become false. So not equal to, how do we write is, you just have to give an exclamation mark and the equal to sign. Some people get confused that they write the equal to sign then give exclamation mark. So this is wrong. Be very careful with that. You have to write this particular one. So let's understand all these assignment operators using a program so that we can get the clear idea about how to use it in a C++ code. So as you can see, I have written down the program in C++ using one particular variable where I have given a value to it and I'm printing it after every operations I have done. As you can see that here int a is 10. Then I did is a plus equal to 10. I have already told you what will be the answer. So that means a plus equal to 10. That means it means a equal to a plus 10. So what it will become? It will become 20 because a was 10 before. So now it will be 20. Now if you see here in the next line, a minus equal to 10. Now many of you may get confused that a is 10 and I have subtracted 10 from it. But actually we have to forget now this because a has changed to 20 in the previous line. And variables are something, it always replaces the previous value. So that means now a was 20. So that means what we will do is a equal to a minus 10. That means it will become 10 again because 20 minus 10 is 10. Now we have the multiplication sign. This time a is 10 because in the previous line it had become 10. So a will be equal to a multiplied by 10. That means it should become as 100. Then we have a divide equal to 10. That means a will be equal to a divide by 10. That is 100 divided by 10, which means it will become 10 again. So we have got all the values, that is, it will print 10 here, then 20, then 10, 100, 10, lastly. So it will print 10, 20, 10, 100, 10. So if I run the code, you will see this is the answer, same as this. So that is how you can use all the assignment operators. It's very simple to understand. Just you have to remember where you have to put the operator that will be coming before the equal to sign for each cases. Welcome back. In the previous session, we have studied about what is assignment operators and how to use assignment operators in C++. Today we are starting the next one, which is the comparison operators. Now this will be a much more easier one because it's simply, you can understand by the word that we are comparing two things. You can compare, let's say, two variables. You can compare two numbers. You can compare anything which you want. And with that, we need some operators in order to compare these two. For example, if I take two variables, let's say a and b, and they have some values. Let's say this has 1 and this has 4. So I have to compare these two, like which one is greater, which one is smaller, are they equal, are they not equal? And here you can take a point note that in the previous session, I have told this operator in the assignment operator, though there is the equal to sign, but this will be coming in the comparison operator rather than the assignment operator. So make sure you correct this one. So by chance, I have told you this in the previous class. So not equal to comes under comparison operators. The comparison operator simply means comparing two variables. The thing about comparison operators is that it will only give you two outcomes. That means it can be either true or it can be either false. Because if you compare 5 equal to 5, we know that it can be true or it can be false. In this case, it is true. So you have to understand this, that comparison operators always gives two outputs. Now the thing is that what are the types of comparison operator that is present in C++? Well, I'll write from the very starting. First, we have the double equal to sign. Now, if you have never studied programming, so what is double equal to is, what does it do is it simply checks whether two variables or values are equal or not. So when you write, let's say 5 equal to 5, we know that we're telling that yes, 5 is equal to 5. But when I'm writing 5 equal to 5, here I'm checking whether 5 is equal to 5 or not. In this case, it is true. That means we do this because when I write a equal to b, let's say a was 1, b was 2. Now since I wrote this, a is equal to b, that means whatever value b has, it will replace a. So a was 1, now it will become 2. Now if I check in the next line, a equal to b, here it will check whether a is equal to b or not. A was 1 before, b was 2 here. Now a became 2 and b also is 2 already. So that means both are equal, so this will also become true. So that is the logic. That is how it performs. So double equal to is the very first comparison operator. The next one is, which I've already told you in the previous one, it is not equal to. Simply checks whether two variables are not equal. If I write a not equal to b, it will check and it will give you true or false. Then we have the greater than sign and the less than sign, which I'm pretty sure you have learned already in your school. One is greater than, one is less than. If I compare, let's say 5 is greater than 4, this will be true. If I write 6 is greater than 7, this will be false. And this in the next one, which is the less than, it's just alternative to it. If I write 4 is less than 7, this will be true. If I write 6 is less than 1, this will be false. Then you can add two more over here. One is called as greater than equal to, and one is called as less than equal to. It does the same thing if your numbers are greater than equal to. Just one point you have to remember here is that it is said that greater than or equal to. So if I compare, let's say 6 is greater than equal to 6. Now we know that 6 is not greater than 6, but 6 is equal to 6. So if there is no or over here, then both the conditions should be satisfied. But since or is there, only one condition if it's satisfied, so this will become true as well, because 6 is equal to 6. So we know that. So that is how all these things perform. And when we will do flow controls and you will learn all the like conditional statements, then I will show you the working of this using a program. There also you will understand it much more better. Welcome back. Today we will do the next one, which is the logical operators. In the previous class, we have done the comparison operators, and today we'll continue with the logical operators, which is extremely important. The logical operators are similar when it comes to the outcome used for comparison operators, because they also have either 1 or 0. That means it can give true or it can give false, because it's just a logic. Logic in the sense that it can happen or it may not happen. So it's simply that logic is there. So when you apply a logic, it will happen, it will not happen. So the two outcomes can be there. So it can be either false or it can be either true. The logical operators are very simple to understand because there are only 3 of them. First, we have the double AND, which is called as logical AND. It is called as logical AND. So what it will do is it will return true only if both the condition are true. That means if you have two conditions together and you have connected them with the AND or the logical AND, both the conditions should be true, then only the outcome will be true. If I give an example, if I write here x equal to 1, and in the next line I'm writing x is less than 4 and x is less than 10. Now in here, if you see x is less than 4, which is true. X is less than 10, that is also true. So here both the conditions are true. So this whole statement will give us true. That is the logic. Then we have the next one, which is OR. Now OR we write using 2 lines like this. What is OR? OR is just a little bit different from the previous one. If I write here x equal to 1, and if I write x is less than 4, or x is, let's say, less than 3. Now here you can see both the conditions are true. But in this case, we'll just check the individual conditions. If any one of this is true, then the whole statement will become true. So that is OR. We either need any one of them from this. That is what OR means. And lastly, we have the exclamation mark, which we call it as logical NOT. It simply gives like this, that if anything is true, it will simply make it false. If anything is false, it will simply make it true. So it just gives the opposite of what you're getting. For example, if I say x is greater than 4, if your x is, let's say, 5. Now I know that this statement will be true because x is 5 and 5 is obviously greater than 4. But if I do a change here, if I write in the next line that x is greater than 4, but in front of it I give an exclamation mark, I know that this statement is true, but since there is a not over there, whole thing will become false, because it is just like this, that you can see this statement. If I bring it here, it is true, but in front of the true there is an exclamation mark. So as I wrote here, if this logic, true become false, false become true, so true will become false here. So that is how it works. Let's understand this much better using a program. Now here I have a program where I have taken two variables a and b, which has different values. In the first statement I have written a is equal to 0, that is I'm checking whether a is equal to 0. And in the next statement I have written here is that a is greater than b. So here if you see that a is not equal to 0, that is for sure, and a is not greater than b because 3 is not greater than 11. So both these cases are false. So when in an AND both things are false, what will happen? It will become false. It will become false. As simple as that. If both the conditions were true, then it would have become true. Let's see the OR one. If you see here, in the first statement is similar. That is, A is checking that A is equal to 0 or not. But A is equal to 3. So this statement is false. Fine. Then it is written that A is less than B. Now, yes, A is definitely less than B. And here OR is given. So if any of the condition is true, which is in this case, this is true. So this will become true. Next, if you see here, the next one, a is equal to 5, which is false because a is equal to 3. But I have given an exclamation mark here in front. That means it is a not condition. So if the condition is becoming false and there is a not in front of it, it will change and it will become true. In programming words, you can say that this will become 0, this will become 1, and this will become 1. So we should get the answer as 0, 1, 1. So if I run the code, you're going to see we're getting 0, 1, 1. So that is how logical operators works in C++. Welcome back. In the previous class, we have learned about how to use logical operators in C++. We have also seen the fundamentals of logical operators, and moreover, we have tried a program to see the outcome. Today, we're going to learn about binary numbers. You're going to have a question in your mind that we have one more operator, which is a bitwise operator. Why we are not doing that, and why we're coming to this something like very different kind of topic. Well, the reason is simple, that for bitwise operator, you have to know what is a binary number, and you have to have the idea about how to find binary numbers. And this has nothing to do with C++. It is just how you can find binary numbers and how computer works from behind the scenes. So I'll just give you the idea about how to find binary numbers from any number you can think of. And I will show you two ways to do that. One is a difficult way, one is an easier way. Like it may be easier for you, it may be difficult for me. So whichever way you find easier, you can choose that. I will show you both the ways. So before we move forward, we have to know what does binary means. So binary means here, bi means 2 in simple words. And I'm pretty sure you may be aware that computer works using two numbers, that is zeros and ones. 0 you can say as false, or you can say low voltage. 1 is called as true or high volt or something like that. This is sometimes called as off. This is sometimes called as on as well. So these are the two numbers, that is zeros and ones, through which computer works, and that only gives everything in your computer performs, and every action and every function, everything performs only because of these zeros and ones. Now you're gonna think that how so complicated things perform using only zeros and ones. Well, the answer is simple. Whatever you do, it actually converts it to zeros and ones and then perform its operation. Since nowadays computer comes with very high-end processor, it is so fast that even it is not very much capturable through human eye. That means, for example, if I'm writing here n, for example, now this also is happening because of zeros and ones. It is taking all those individual pixels and then converting it, and then it is displaying. So if I have to give you the idea about how binary number works is, first, let's say if I have written number 25, it will be converted to binary code, which the computer only understands. There may be other steps in between, but those steps I'm skipping right now because you just have to concentrate on how to find a binary number from a number. So when this computer understands this number, it will figure out that you're asking about 25. Then it will return back through the same steps where this number, which the computer have understand, which is in binary form right now, it will again convert back to 25 because the human should understand. Not every human knows what is the binary of 25. Then it will give it back to you. So this is a whole cycle which keeps on getting. Like if you press 2 in your keyboard and you see 2 in the screen, this process happens behind. 2 will be converted to binary, computer will understand, it will get back to you 2 by converting that binary to 2, and then it will display to you. Now how this conversion happens? So let's learn that. Let's say if I have a number, let's say 5. Now I have to represent 5 using zeros and ones. Now I will show the first method, which I feel is a little bit difficult method and a longer method. Why it is difficult, why it is long, that also I will tell you. First you see the method. What I have to do is, and one point you can note here is that for binary, 2 is their favorite number. Why? I will just tell you right now. Why 2 is favorite for binary? When you have any number, let's say 5, first I will divide it with 2. So there may be other divisibility technique from wherever you're watching this video, but this is how we divide. So how we are dividing it is that I know that 2 into 2, if I divide like this, for example, if I write here 5, 2, 2 2s are 4, remainder will be 1. So that means I will write this directly. That means I will write here 2, 2 2s are 4, remainder I will write on the side 1. Fine. So it's simply 2 multiplied by 2, remainder will be 1. That is how we will get 5. That means I have to multiply this two things and then I will add it to this. So I will get 5. Next I will again divide. 2 1s are 2, remainder will be 0. Fine. Now the binary of 5 would be these numbers from the reverse way. So that means 5 is actually in binary we write as 101. Let me show you with one more number. Let's take this time 9. 2 4s are 8, remainder will be 1. 2 4s are 8, remainder will be 1. Then I will divide it. 2 2s are 2, remainder will be 0. 2 1s are 2, remainder will be 0 again. So 9 we write as 1 0 0 1. And remember, it starts from here and then it goes up. So this one is the first one and this one is the last one. Now you may have one question that till where we have to divide. So you have to divide until you find 1 at the bottom. If I take a bigger number, let's take for example, let's take 31 for example. 31. It's a bigger number. So let's divide 2. 2 1s are 2, remainder will be 1. Then 2 5s are 15. So 2 15s are 30, remainder will be 1 here. Fine. Then we have 2 7s are 40, remainder will be 1 again. 2 3s are 6, remainder will be 1 again. 2 1s are 2, remainder will be 1 again. And since we have reached 1 here, I don't have to divide anymore. So the binary of 31, if we go this way, it will be 1 1 1 1 1. So there's a problem. What is the problem using this method is, for example, you can do 5, 10, 15, 30. That's fine. But what if you get a number like this? If I have 5041, how long do you think it will take us to divide these numbers? So it will take quite a lot of time. So to solve this way, there is one more easier method. So the easier method, it is very simple in order to do it, because you don't have to divide and all those things. Just you have to remember the double of the number. For example, if I write here, let's take one bigger number this time. Let's take 19. Now to find the binary of 19, what I will do is, see here very carefully. First, I will write 1. Now tell me, what is the double of 1? It is number 2. What is the double of 2? 4. Double of 4, 8, 16, 32, and it will keep on going. Now, the point is that what you have to check? You have to check first the number, which is 19. Now, 19 is less than which number? That means 32. 19 is less than 32. We have to go till the highest number. That means 16 is just lower than 19. So we don't need all these numbers then. We need till 16 only. So you have to check till which number that particular number which you have taken is greater. Okay, if in case I had 41 here, so I would have taken 32 as well, because 41 is greater than 32. Then 32's double is 64. I would have not taken this because 64 would be greater than 41. So that is the logic. Now if I write here 16 18 16 8 4 and 2, now let's find the binary of this. Very simple. First, if you see the first number and here the first number, I will simply subtract them. So this will be 3. Right? So if I take 16 here, 3 will be left. So I will take 16 here. I will put a dot on top of it. Then I have 8. Should I take 8? I have only 3 left. So 8 won't become. Then I have 4. 4 also won't be coming because I have 3. I need 3. I don't need 4. I don't need more. I need less than 3 or equal to 3. Then I have 2. 2 I should take, because if I take 2 here, subtraction, it will stay 1. So 1 is also there. So 1 also I have taken. Wherever you see the dot, I will write a 1 on the bottom and the rest will be 0. So this is the binary of 19. I will show you one more time. This time I will take even more bigger number. Let's take 57. Okay. Same way. 1, 2, 4, 8, 16, 32, 64. Now we will not take 64 because it is greater than 57. So we'll stop on the 32 again. First I will subtract 57 and 32. 25 will be remaining. 25 will be remaining. So I can take 32 here. Fine. Let's give a dot on top. Then I have 16. If I subtract 16 here, this would make it as 9. So I have 9 now. So I can take 16 as well. Then I can take 8 also because remainder after subtraction it will be 1. So I can take 1. Since I have left with 1, I will take 1 from here as well. So that means 1, 1, 1, 0, 0, 1. This is the binary of this number. So it's a very easier way to find binary for larger numbers from the previous method. Okay, welcome back. In the previous class, we have studied about what is binary numbers and how binary number works and how you can convert a number into a binary number and the reverse of that. Today, what we're going to do is we're going to do the bitwise operator in C++. The bitwise operator, if you want to know, if you have not seen my previous lesson, you should watch that because without knowing binary numbers, you cannot do bitwise operator because binary numbers and bitwise operators are related. Now, I'm assuming you have seen the lesson of binary numbers and we will start the bitwise operator and how bitwise works. So bitwise operator generally, as the name suggests, it works on bits. So bits are something like if I write a binary number, let's say 1, 1, 1, 1. When I write 4, 1, I know this is the number 50. Now, if you see over here, we have 4 bits. 1, 2, 3, 4. So that means on individual bits, when we do certain operations, we call them as bitwise operator. And bitwise operator are of 6 types generally. The very first one is the bitwise AND. Bitwise AND. Then we have the number 2, which is the bitwise OR. Or generally we write single line like this. So it is bitwise OR. The third one, we call it as bitwise OR. The fourth one is left shift. And the fifth one is right shift. And the last one is bitwise NOT. And we'll see them individually how it works. If you understand one, I'm pretty sure you will get the other ones also, but still I'll try to explain all of them once. So over here, we'll start with the bitwise AND and we'll see how that works. So when we have the bitwise AND, for here, you have to know one thing which is called as a truth table. Now, what is this truth table is? Truth table basically gives us the idea about what kind of outcome we will get when you do certain operations with binary bits. For example, if I have to draw the truth table of AND, so we have, let's say A, B, A and B. So we have two inputs here and the A and B is the output. So input I can give, there can be, since two inputs are there, so 2 to the power 2, 4. So that means 4 numbers here, 1, 2, 3, 4, 1, 2, 3, 4, and 4 outcomes will be there. So what are the different possibilities that can happen is, I can write here 0, 0. A can be also 0 for the first input and B can be also 0 for the second input. Then we can have 0, 1, 1, 0, 1, 1. These are the possible inputs which we can give. So let's say if A is 0, B can be 1, B can be 0 also. So that can be possible. Now how it works is, you can simply think this in a very simple way. If you're not able to memorize this or if you're not able to get this, you can simply think that this truth table of AND is simply multiplication. That means I will take these two, multiply, I will get the answer as 0. These two multiply 0. These two multiply, these two multiply 1. So this is the outcome of an bitwise AND for certain inputs. Now let's see some operations of how it works. Let's take 15 in bitwise. So this is 15, I have already told you. And let's take 10. Now if I do AND over here, if you see, I have already shown you the truth table. You can also say that, clearly see that 1 and 0 will give us 1. We just have to multiply. It will be 0. 1 and 1 will be what? It will be 1 as well. 1 and 0 multiplication, that is 0, and 1 and 1 multiplication 1. So I have got 10 again. So 15 and bitwise 10 will get 10 again. So that is how the logic is. If I show you the OR one is a little bit different. The truth table will be a little bit different here. If I have to draw it, here A, B, and we write A and give a dash like this and write B. So input obviously will be same because those are the possible inputs for a truth table, for every single truth table if there are two inputs. And here what happens, you can think it like a plus or a addition. That means 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. Now here the confusion comes at the very last one. This you have to understand. I have 1 and 1. I know that 1 plus 1 is 2, but I cannot write 2 over here. Writing 2 is not possible when you're working in binaries because we know only we can work in 1 and 0s. But I know that I can write 2 in 1 and 0. Now if I have 1 and 0, which is having the higher priority when it comes to 1 and 0, so it will be 1 and not 0. That is the highest number. So for here 1 plus 1, we take 1 over here as well. That is the reason. Don't get confused on the last one. 1 plus 1, we get 1 when we are doing binaries over here. How does it work? If I take the same piece of number, that is 10 and 15. So if I write here 1, 1, 1, 1, 1, 0, 1, 0. If I have to do an OR, I just have to add. That means you can do is like you can write the add sign also. 1, 0 will be 1. 1, 1 will be 1. I have told you the reasons just now. 1, 0 will be 1 again, and 1 will be 1. So I'm getting 15 here. Right? So that means for OR I'm getting 15, for AND I'm getting 10, right? So that is how the thing works. Then we have the XOR. We write the XOR like this. It is just like OR only. Little bit difference is there. I'll make sure the difference. For this, what happens is if you see 1 in any of, like in just one of the inputs, it shouldn't be both. It should be only one. That is the rule. If on any one of them 1 is there, it will be 1. Rest will be 0. That is how XOR works. So it will be, if any of the single one is 1, then only it will be 1. Otherwise it will be 0. If both are 1, still it will be 0 as well. That is how XOR works. Now we have left shift and right shift. That I will explain you in the program itself and even the NOT. So let's move ahead to the program. So as you can see, we have made a program over here where I have taken the number as 15 and 10, which I have even told you in the example as well. Here, if you see, first we're printing the 15 and 10. Then what I did is over here, if you see, we did AND. I know that when we did AND, I have shown you also we should get 10 over here. That should be displayed. For OR, we should get 15 over here. 15. Now, this is XOR. Now, XOR, how it works is I have told you that for if a single one is 1, then it will be 1 here. So the answer for this one would be if I'm taking 15 and 10. So I have written here 15 and 10. So if you see here, only on the second part here, this is 1. Only 1 is there, and this is 1. So this will be 1, this will be 1, rest will be 0. So I'm getting this part. This 0 doesn't make any sense. So this one. So what is 1, 0, 1? So this will be 1, 2, 4, 5. So I'm getting the answer as 5. So here it should print 5. Then we have the bitwise NOT. Now bitwise NOT you may find a little bit complicated. So let me show you over here how it works actually. So we have the number 15, which is 4 ones are there. This is 15. Now in the program, I have written here NOT of A, that is NOT of 15. NOT, what it does is it simply changes the bits. That is, it inverts the bit. So that means everything will become 0. But if everything becomes 0, it will become 0 only. So what we do here is whenever we have to work on like any number of bits, we put a 0 in front and then we do the NOT operation. So what will happen is everything will become 0 and this first one will become 1. If you see this closely, this is 16. And since we're doing the NOT operation, minus sign will come over here. So that means if NOT of 15, we get here minus 16 as an answer. Now we have the right shift and the left shift. So first we'll do the left shift, and as you can see, B, we are doing left shift with the B with number 1. You can do left shift with as many numbers as you want. Right now I'm taking 1 here just for you to explain it. So we're doing on B, that is on number 10. So we'll go ahead to the over here. If we see, I have written here number 10, which is 1010. This is 10 in binaries as you know it. So what we are doing is we are doing left shift over here. Now what is left shift is it will shift the bit in the left hand side. So if I write here 1010 and this 0 will come on the left hand side, that is this. Let me change the color. Then this 1 will come here and this 0 will come here, 1 will come here. So what will it become? It will become 0, 1, 0, 1 and a 0 will come here. I'm pretty sure you know what does this means. This is 20. If I write 1, 2, 4, 8, 16, is 1, 0, 1, 0, 0. So 16 plus 4 is 20. So that way you can do the left shift on this. Similarly, it happens same with the right shift as well. If you do right shift on number 10, you will get the number 5. So we're just shifting the bits on the right hand side depending on which number is provided. So now if I run this piece of code, you're going to see the answer as 10, 10, which is the first we're printing 10, 15, then 5, minus 16, 20, and 5. So those are all the bitwise operator which are found in C++.
Come back. In the previous lesson, we have finished operator section and we did the last one, which is the bitwise operator. Today we are doing input and output. Till now you have seen majority of the output things, but I have not shown you how to do inputs. So inputs is very important because we have to give something to the program, and with that the program will decide what output it will give us back. So input means simply what we give to the program. Okay, so it is very easy to understand input. Output, you already know that we use cout and we give this bracket, right? But here in input we change it, we write cin, that is console input, and we give the reverse of that bracket, right? So let's write a very simple program so that I can explain you what exactly we are doing over here. Okay, so over here, first what we will do is I will make a variable. Let's write int a, and this is a variable, and I have to take an input on this variable since it is an integer data type. So I will take a number over here, and after that I will simply display it to the console. So how will I do it? First I will write professionally that I will write enter a number. If you want, you can give a ENDL as well. It will look much better. After that, how do we take the input? We write cin, then we give the bracket like this, and you have to write the name of the variable. So what it means is I have taken the input on this variable. Now in the next line, if I print the number is, and if I run the code, so you will see that here it is waiting here for me to put a number. So let's put 15 and I press enter. As you can see, the number is 15, right? So this is perfectly working. So that is how we do input, and that is how we do output. And there is no limitations of how much input or how many output you can do in a simple program. You can do as many as you feel like, right? But you have to be very careful that input only will work inside the scope. Like for example, if I write here, let's say on this part, cin a, this will not make any sense and it will throw me an error. As you can see, it has turned black in color. So that means there's an error over there. So be very careful on where you are taking the input. And one more thing, that is it necessary to write this line? It is not, because if I, for example, if I comment this, if I run the code, still it will work. Okay, it is not mandatory to give, but actually it is very important in one sense that if I write only cin and a, I know that I have to take a number. How will the person who is using your program or using your whatever program you have made, how will he know that what kind of input that person has to give? Here I have clearly mentioned that enter a number. So if I don't give this and I run the code, it's fine, it's waiting, but I don't know what I have to do. If I have no knowledge of programming, it's just waiting over there. I can type anything. Let's type a word, let's say hello. So if I type the word hello and I run the code, it will say, it will give me a garbage value because hello is not a number, it's a string, right? So those kind of things you have to have in mind, right? This is optional, but you have to write it because to make the user know that what exactly he's giving. So enter a number, right? And it is not necessary that you have to write enter a number only. You can write as how you feel like, but something you have to mention so that the user knows. And you can take different kind of data types also. Let's take float. And if I write here, first I will mention here that the integer number is, and then I will write here cout, enter a number with a decimal point. So I've clearly mentioned what kind of number I'm looking for. So I will take cin. So it doesn't matter what data type you're using, cin and written format will be same, just the variable will be different. So I will simply print it, cout, the floating point number is, I will give ENDL over here. And if I run the code now, it will ask me two numbers. First I will write a number 5 and press enter. So integer number is 5, then it's asking the next number. Now as you can see, the number line is getting connected, so let's fix that. I will put the ENDL over here also front so that it looks nice. Now if I run the code, let's type 50. 50. Yeah, the integer number is 50. Now asking a number with a decimal point. Let's write 7.8543. 7.85. Press enter. So it's giving me the answer 7.8542. You can do this with every single data type, okay? Except string. String also has a other way of taking input. That also I will show you when you will learn strings. Okay, because for string there would be one particular lesson only. So that is how you do inputs and outputs in C++.
Welcome back. In the previous class, we have seen how to do input and output. Today, we'll discuss about what are strings in a much more detailed manner. Strings are probably the most important kind of data type which is there in C++, and we're doing a detailed class on it because of its importance. Now first we'll see what the string means. So string, the definition of string is simple. We call it as a collection of characters. Right? So it can be any characters, whether it's a special character, normal character, alphabets, numbers, anything. But here you have to note this, that it should be either inside double quotes or inside single quotes. Generally, to make it simple, we don't use single quote when you're using strings. We do it only with characters, but there is no hard and fast rule that you have to use this or you have to use that, whichever you feel better. But generally, when you will see the program, you'll see the double quotes on. Now, how do we write a string? For example, let's say somebody's name is there, John. Now, John, we are writing in double quotes, and it is a collection of characters, right? 1, 2, 3, 4. 4 characters are there. So it is a string, right? If I write here 413, this is also a string. It's not a number because it is under the double quotes, right? If I write only 4 and give a single like this is a character. This is not a string. It is not collection of characters. It's a single character. So that difference you have to understand, right? But there are certain operations when we have to do in strings. Okay, but before operations, we have to know that whenever you're doing strings, okay, this thing is not necessary in all compilers, but some compilers gives error if you don't give this. So we have to give a header file for strings. We write include string.h. This is the header file we have to put when you're starting a string program if you want to use functions from the string library. Okay, and that also I will show you what kind of functions are available in the string library. That also I will show you. But let's understand with the help of the program that how string works. So I'm currently in the platform, and let me give the header file first. So as I said, it will be string. So I've included the header file, though it is not necessary on this compiler, which I know that I have using this compiler for a very long time, but still you have to make a habit that you have to include this, okay, because you never know which compiler will give the error. So let's take an input and output and simply print it. So I'll write here string name. So I've made a variable name and with the data type string, and let's take an input cout, enter your name, cin name. Now, generally, when you're taking string inputs using cin, you will face a problem. Okay, that problem also I will show you. Let me first print the name. Your name is. So let's run the code. So it's asking me a name. Let's type John and press enter. As you can see, it's giving me the correct answer, John. Now, let me tell you what is actually the problem of using cin, right? So if I run the code one more time, let's type a name. My name is, let's type Carl John William. So this is a full name of some person. I have typed this, and if I press enter, can you see the problem that it is only giving me Carl, right? It is not going after the gap. So that is a big problem of cin. Okay, if you're using cin, you cannot put a full name or you cannot put something with gaps, right? So how to fix this? So for fixing this, we have one string function. Okay, that will take a lot of memory if you compare with cin, but it will work for full name also. So let me first comment the cin, and I would write here. The function name is called as getLine. And since it's a function, we will give bracket like this. Okay, this is how we write functions. Okay, name of the function and then 2 brackets. And inside here, first I will write cin, comma, the variable. So variable is name and give a semicolon. Now if I run the code, so let's type the same name again, Carl John William. So as you can see now, that it is giving us the full name. So that is the advantage of using getLine. Though it is a function, it takes a lot of memory or a lot of resources, but it will give you the desired result. Now, let me show you something else over here. Now, let's say if I write here the variable, let's write string first name and string last name. So 2 variables I have made, which is the string first name and string last name. So I will take the input cout, enter your first name, cin first name, cout, enter your second name, or the last name also we can write cin last name. So I've taken the input for the first name and the last name, and now I will display it. So I'll write string full name equal to first name plus, let me give a gap here, and then last name. If I print this, you're going to see that it's asking me 2 names. So I've type John William, and as you can see, it's giving me the full name now with the gap as well. So I can take one string and I can take another string and I can connect them. This connection of 2 strings is called as concatenation. This word you have to remember. When 2 strings are joined together, we call it as concatenation. Okay. And there is one more operation which I can show you here is that I can write the length of the name is, I can use a function which is called as dot length. So as you can see, this is the function. Okay, this will give me the length of the name. So if I run the code right now, and if I type the same name again, John William, so length is 12. Right? So this things also you can do over here. Moreover, you can do certain operations which you have already learned before. Okay, from the operators section. Those operations are also applicable in the strings.
Welcome back. Today we're discussing about math functions present in C++. You may till now be very clear about that it is important to use mathematics in programming in order to do certain operations. So in C++ also, it allows us to do certain maths operations very easily using certain functions. And that is what we have to learn today. So it is pretty much clear that when we talk about maths function, it will have certain operations of maths. If I give one example, let's say we have 2 to the power 3. So this is a maths problem, and we have to do, I can write this as 2 multiplied by 2 multiplied by 2. So basically, these kind of problems, rather than writing in this way in the longer format, how can we write this way in C++? If that is the case, what if we have something like this scenario where we have the problem in such a way that, let's say if I have 144 square root. Now we know that the answer is 12, but how do we write in this format in C++? For these kind of problems only, we have certain maths operations which are being made. Now, before we use any of the maths operation, you have to know one header file which we call as C math. Now this header file will have all those libraries which will help us to do all those functions like maths operations, which we have square root, and then we have other like round functions, we have float, ceil, each and every basic functions that I will show you today. So how do we write in the starting of the program, after we have written iostream or input output stream.h header file, we will write hashtag include cmath. So this is the way of writing the header file, and when you include this, then only you will be able to do math operation. Otherwise, it will throw you an error. So make sure that if you're using any math operation, remember that this is included at the top. The first one, as I gave you the example of 2 to the power 3, how do we write this using this? So in C++, the function name, we call it as pow, and we write 2, comma, the power of it. So this is how we write it. So when you write this, it will throw you the answer as 8. So you can write anything over here. Let's say if I write 5 to the power of 3. So this should give me 125, because 5 into 5 into 5 is 125. So this way, using the pow function, you can immediately get the answer of it rather than multiplying the same number several times. So this is the first function, which is called as pow. Second, which we did is we did the square root. The square root is directly as it said, we write SQRT, everything small, and inside the bracket, we write the number. So this will give me 12. If I write, let's say SQRT, if I write 169, this will give me 13, like that. So you can use different kind of numbers which are perfect square, and you can put inside it. If by chance the number is not a perfect square, then it may throw an error on some compilers. So be very careful with that. Next, we have two functions. One, we have the floor, and another we have a ceil. Now these are two interesting functions because one gives the floor number and another gives a ceil of the number. What does it mean? For example, if I have a number, let's say 4.6. Now for the 4.6, if I found the ceil, so it will give me 5. That means it will try to find, the ceil function will try to find that which number is closer to this particular fraction. If I take, let's say 3.2 and I go for the floor, it will throw me 3 because it will find from this side that which is the lowest one of this fraction value. So that way floor and ceil function works. Now then we have the function which we call as abs, or in full form we call it as absolute. It will throw you the absolute number. That means if I write here -8 and I write inside the abs, what is the absolute of -8? It is 8. That is the absolute value because we are only concerned about the value over here. So that is how abs work. Then we have two more functions. One is log and another one is exponent. So if I write, let's say log of 5. Now for this we have the logarithmic table, but if you remember the value, I know that it is 1.6. If I have exponent, let's say if I write exponential value of any value, if I write here, it will throw me the exponential value of that particular number. We write exponents as e to the power something, whatever number will come over here. So let's say if I write here 5, so e to the power 5, whatever the value will be, I think it will be something as 148 or 149, something like that. So that number will be displayed. So let's see all these functions which we have learned in a program and see what outcome we get. So as you can see, I have the program over here, and here I have written some values, and moreover I have written all the functions. So as you can see, first we have the pow of 2 and 3, which we have already taken. Let's take some other values over here. Let's take 4, 3. Now this means that we are multiplying 4 3 times. So 4 into 4 is 16. Then 16 into 4 will be 64. Next we have square root of 49. We know square root of 49 will be 7 because 7 multiplied by 7 is 49. Then we have ceil of 3.8. As I said, it will find the nearest integer. So 3.8 will become 4. Then we have floor of 2.3. it will find the nearest integer from the left hand side, that will become 2. Now this is the absolute value of 3.1416. It will throw the same number as, because we just need the absolute value of. Then we have log 5. It should give something 1.6. Then we have exponents of 5.0. This should give, I think it will be 148 or 149. So let's see what will be the outcome of these numbers. So if I run the code, as you can see, 64, 7, 4, 2, same number 3.1416, 1.60944, 1.6, 148.4, 148 or 1. So I was pretty close. So these are the math functions which you have to remember of how they work. But don't think that these are the only maths function in C++. There are so many, but right now, since you're in the very basic level, so you have to know all these math functions. And when we move forward, there are sines, cos, and all those kind of advanced kind of functions are there when we do math with C++. Welcome back. Today we'll learn about what are conditional statements in C++. Conditionals are also known as decision makers. Now, what does this means as we have to understand? That's very simple if we see in one way that we have a condition and because of that condition, some outcome will happen. For example, let's say I will go for a walk today evening. Now, suppose this is a sentence. This is let's say an outcome which you want to do. Now there are various conditions that depends on this statement. Let's say in the evening, let's say if it is raining very heavy, will you be able to go for a walk? Probably you can, but then you have to change the condition that you have to take one umbrella. So condition, depending on the condition, your outcome has changed. Even though you're going for a walk, you have to take an umbrella. So depending on the condition, the outcome changes. Same goes with programming. Let's say if I'm giving a piece of data somewhere, if the person is not receiving the data, what will happen to the data? So in that condition, whatever outcome I have decided for that piece of data, that will happen to it. So every piece of instruction or every piece of command, certain conditions are there. And depending on that condition only, you will get one output. If a condition is that tomorrow you will be 10 years old. So if that is the thing, can this condition be changed? It may not, because tomorrow, if your birthday will definitely come. If it's a birthday tomorrow, so you will be 10 years old. There is no else part over here. It will be that, yes, tomorrow I have my birthday. Whether something happens or not, I will be 10 years old. For these kind of statements, condition won't play much of a role. Yeah, it can happen that you may not be able to celebrate your birthday. That can be one thing. But certain statements are there which does not affect what condition you have put. But for now, we will see the condition which will get affected. For example, if I say, let's say you study in a school and from your home till the school, it's a very long distance. So let's say, for example, if this is your home and let's say this is your school, you have, let's say, 5 roads to it. Now, if I ask you which road you will take, with the help of common sense, a person will select the center one because it is the shortest road. But what if I say that there is construction going on over here, so you cannot go through the road? Then you will choose some other road. Now, because of the condition of this construction, you have changed your outcome. Same thing will happen with a program also. And for this, we have all these conditional statements. And today we're going to learn about if-else statements. Now, as the name suggests, it is something like if condition happens, then this outcome will happen, else this outcome will happen. Something like that. Let me give a clear idea about it. Let's say if I write here, if A is greater than B, then what I will do is I will do A plus B and I will put it into C. Else do C will be equal to A minus B. So here if I say A is 14, B is 12. Now if you see very carefully, the condition we have to check if A is greater than B. So A is 14, B is 12. So definitely 14 is greater than 12. So this condition is satisfying. So it will come here directly. That means C will become 14 plus 12. So it will become 26. And this else part has nothing to do with it right now because the condition has been satisfied. So we will not move to the else part because it will only check the condition. If this condition is false, then only we'll go to the else. Let's see one more. If I write if, we'll consider some different numbers now. A is 5, B is 16. If I write if A is greater than or equal to B, then you do is C is equal to A minus B. Else C is equal to A multiplied by B. Now if you see this condition, here I have written A is greater than or equal to B. Now I have to see A and B. Are they greater? No. Are they equal? No. So this condition is not satisfying. So this thing will not happen. So it will directly come to the else.
It is written here A multiplied by B. So A multiplied by B is 5 multiplied by 16. And the answer of this, which is 80, will be stored in the C. Now, if I have to show you this with the help of program, let's see how it works. So here I have made a very simple program of taking an input from the user, and I have put the condition that if the input is greater than 0, the number is positive. And I have also written a cout statement where the statement will always execute. Now if I run this code, let's see what happens. So it's saying me enter an integer. Let's type a number. Let's put 6. And if I press enter, you're going to see you have entered a positive integer 6. And at the bottom, it's written this statement will always execute. Now what happened here is, since I have given the number input here, I will write here in the comment as number 6. So now we know that 6 is definitely greater than 0. So this statement will be printed, and we are also printing the number. But this statement, which is over here, it has nothing to do with the if block. It is just outside of it, because as you can see the code. So when I write a cout statement in a C++ program, it will always print. There is no condition or nothing else provided over here. So this statement will always execute. So that is how if works. If is very simple. You just have to see the condition over here. If the condition is satisfying, then whatever is inside it, that will always run. Next, let's try the else part. Now for the else, what we will do is we can write like this. We can write else, give a quote like this, and we can write any statement over here. Let's write hi. So I'm just writing a random statement for now, just in case to see whether it's going to print or not. So if I run the code now, let's say, since I know that the condition should not be satisfied in order for the else part to run, so I need a number which is less than 0. Because the condition should not be satisfied, then only we will get the desired output. So I'll put, let's say, -9. And if I press enter, it should be printing me hi -9, because now the condition is not satisfied. Number is not greater than 0. So it is printing me the else part. The next we can write is, what if we put one more condition, but this time we'll do with else if. Else if is something like this, that if this is not satisfying, else if do this. So that is how it works. So I'm going to write here in the next one, I will change the condition and the statement. This time, if you put a number less than 0, you have entered a negative integer and the number will be printed. And for the else, I will put here that you have entered 0. So that can be the only condition, because if the number is greater than 0 and if the condition is less than 0, in the middle there is only 0 that you have given as input. So if you give 0 as input, it should be printed that you have entered 0. So now if I run the code, let's see what happens. So let's put a number, let's say I put 0. And if I press enter, as you can see, you have entered 0. And this statement will always run because there is no condition with the statement. This is just a cout statement. So it has nothing to do with all these things. Just one cout statement printing always, nothing to do with the conditions. This is how if else if work. Moreover, you have to remember one thing, that you can put as many else if as possible, because there is no limitation to that. You can do like this, that if this is not satisfying, else if this, then again else if the previous else if is not satisfying. So you can put as many conditions as possible. But one thing you have to keep in mind, that for one if, there'll be only one else. Welcome back. In the previous class, we have done the if-else statement, or the decision making in C++. We have seen how if-else works, and moreover, we have seen how we can implement it in a program. Today, what we're going to do is, today we are starting what we call as nested if-else. A nested if-else is also a very important topic. It is related to if-else, so you will not have any issues in understanding it if you have understood the previous lesson. But if you have not seen the previous lesson, don't watch this now. You watch the previous lesson first and then come back here. Otherwise, you may not understand what we are doing. Now, in the previous class, we have seen how if-else work is that we have if, and then we have condition over here. And then we have some statements, statement 1, then we have else or else if, and then we have further statements. Now, what is nested if-else? In simple words, we can say that it is like one if-else statement is put inside another if-else statement. What does it mean? For example, if I write something like this, if A is greater than B, and I give the curly bracket here. Inside here, I write again, if B is greater than C, then I will do A equal to B plus C. So this is suppose a statement. Here I have A equal to 1. Sorry, I'll write A equal to 2, B equal to 1, and I will write C equal to 0. So if I see over here in this particular statement, you can see that A is greater than B, which is obvious because 2 is greater than 1. Then it will come inside whether B is greater than C. Yes, 1 is greater than 0. So this will work. What will happen is B plus C. What is B? 0. Sorry, B is 1, C is 0. So this will be 1, and 1 will replace the A. What was A? It was 2. Now A will become 1. Let's understand this a much more better way with a program. So as you can see, I have made a program using nested if-else. Here, what I have done is I have taken an integer variable I where I have put a value 5. I have done the first if statement where I have seen is equal to 5. So whether I is equal to 5, yes it is. As you can see here, I is equal to 5. Then in the next line what I did is if I is less than 15, which is also true because I is 5, so it is always less than 15. And then I'm doing a cout statement. So that means this line will definitely get printed. So I'm going to use a comment and write printed. This will definitely get printed. Next, I did one more if statement where I have written here I is less than 12. That is also true because I is 5, so 12 is obviously greater than 5. So that means this statement is also true. So this will also get printed. Else I is greater than 15. Now this else is of this if. If this condition is true, if I write here, which is this is true, it will not come in the else. It will not come here. So this thing will not get printed. So if I run the code, we should see I is smaller than 15, I is smaller than 12 too. But this will not get printed. If I run the code, as you can see, I is smaller than 15, I is smaller than 12 too. Welcome back. Today we're going to start what we call as ternary operators. Now ternary operators has also one more name which we call as a shorthand if else. It is called as shorthand if else statement. What does it mean is basically it is simply just like if else. There is no difference about it of how the thing works, but it is actually smaller when we write the code. Like when we write if else, it takes around like 5 to 6 lines of code. But when you do ternary operator, it will be done in just one single line. If I have to show the syntax of a ternary operator, how we write it is. Now the syntax of writing ternary operators, generally what we do is we write it as we write first the condition, and once we have the condition, we'll give a question mark and then we'll write the first expression over here, colon, second expression over here. What does it mean is how it's going to work is very simple to understand. Here it's going to be a condition. Let's say if it is a greater than b. So if this is the case, if I write a is equal to 2, b is equal to 0, so this condition is satisfying because 2 is greater than 0. So that means this is true. If this is true, this expression will run. And by chance, if I write a is equal to 0, b is equal to 2, then the condition will be false. Okay? This expression will run. So it's just like a shorthand if else. You will understand this better with a program, which I'm going to show you right now. So as you can see, here's a program written in ternary operators. What I did is I took a variable marks using double data type, and I have took the input for the marks. So you can enter any number. Here I did is I made a string variable result, and what the condition I put here is if the marks is greater than or equal to 40, then the person will be passed, otherwise will be failed. So it's similar to like this, that if this condition is true, pass will be printed. If this condition is false, fail will be printed. So this whole thing, this whole concept is the application of ternary operators, and it will simply print your result for the exam. So let's try this. If I run the code, let's say if I give exact 40 and if I press enter, it shows that you passed the exam. Perfect. Now if I put a number which is less than 40, let's say I tried 38 and I press enter, you failed the exam, as you can see. So basically what ternary operator do is it actually works same as how an if else or if block work. Here we have the condition checks itself. If it is true, the true part will run or the true expression will run. If it is false, the false expression will run. The only difference you can think of is ternary operator we write in one single line, whereas if else it takes like 3 to 4 lines, depending on the condition and depending on what expression you want to do. So that is the reason we call ternary operator as a shorthand if else. Welcome back. Today we are learning about switch statements in C++. In the previous class, we have studied about ternary operators and how it works, moreover, its implementation in a program. Today, we're learning about switch statements in C++. Now, what is this switch statement? It's in simple words, what it does, it simply evaluates certain things. But it is a little bit different of how if-else work, but it actually does the same thing. It's evaluating certain conditions and then giving the output. Now, what it does is actually, it has one very important word from switch statement which we can take is the word called as case. So it does not actually check for conditions, it checks for cases. Like if that case is present, then whatever is inside that case, that will be evaluated. So you can think it like a ladder of if else, with a lot of if else are present, and that is how it performs. But it is a little bit different of how if else works and how switch works. So that difference is also I will let you know. Now here actually we can create like different cases for different values for the switch expression, and moreover we can like specify any number of cases in which switch statement, but the case value can only be 2 types, that is which we have learned in the data type, int or character. Remember, if you give the case in other data type like float or any other data type, it will not work. So you have to note this down, that int and character only works when you're putting it in the case. So the best way to understand switch statement is through a program. So let me show you a program of how exactly switch statement works. So here I have a very simple program of switch statements and the cases. So what I did over here is, first inside the main function, I have taken a variable x, which is a character data type, and taking a character a, which is in capital letters. Then what we do is we write the word switch and we pass whatever the variable that we have taken. So this variable will analyze each cases that we have written here. Now I know that my x is here and x is here. So that means this a will come inside here. So here it will go as capital A. Now it will check every single cases of if capital A is present in any of the case. As you can see, it is present in the very first case. So it will come inside it and it will print choice is A. And then we have a word called as break statement. What does break means is simply it will break out of this case and then entire program will stop. That means we don't want, like if this case has been found, we don't want it to move forward. Because let's say if our program A has found over here, I don't want it to check for these cases. That I don't want. So I want to break over here in the program and the program will stop over here. So it's very simple. It just evaluates the case. If that case is present over there, then it will go inside it and it will print it. Now over here, as you can see, there is one word which we call as a default case. A default case is very important because if by chance it can happen that if any of the cases which you have written does not match, suppose let's here, if D was here, now D is not present in any of the case, then the default case will work and it will be printed out the C out a choice other than A, B, C. And then here also it will break out. So now using D, if I run the code, it will be printed a default case, as you can see, choice other than A, B, C. If I write A as previously it was, and if I run the code, choice is A. So it works just like an if and else, but the way of doing this is a little bit different because there it checks condition, here it checks the case of which case variable the switch statement is currently right now, and then it is printing out whatever is inside that particular case if the case is matching. Now this is a very simple code of how switch case works. Let me show you one advanced code of how you can do mathematical functions as well using switch cases. So let me show you that. So as you can see, I have a program over here where I have used switch cases in order to make a simple calculator by printing out all the 4 important operations in maths. So very basic operations I'm doing, like addition, subtraction, multiplication, and division. So how it works is, let me show you. First, what I did is I taken variable OPER, which is in short form operand, and I have taken as a character data type. Then I take 2 numbers, float num1 and num2, and then C out, enter an operator I have taken. So whichever operator you want. So you have to give the input of the operator, that is plus, minus, that is symbols of them. And then I have took the input of both the numbers. Now here you have to remember that, as I told you, OPR can only be int or character. So if by chance I wrote here float, then it will not work. So you have to be very careful with that. Then what I did is I choose for the case plus. The single quote is provided because plus is a character. Plus is not a number, plus is not a string, it's just one single character. So single quote is necessary. For example, if your program was like this, that I am doing for this case 1, case 2, then I don't have to give any single quote. I will directly write number 1. So that is the difference. So that difference you have to know. Now, if I have given the input of plus and I have entered 2 number, it should print me out the addition of both the numbers that I have given as input. Then the statement will break out and these things will not run because I only need the addition. I don't need subtraction. I don't need division. I don't need multiplication. If let's say I need division, so they will skip all these things and only division will come. And this line will be printed and then it will break and program will stop. Let's see if this program is working or not. If I run the code over here, so it is asking me to give an input of an operand. So I will give multiplication and if I press enter, it's asking me to enter 2 numbers. Let's put 5 and 6. Now after I have given 6, if I press enter now, my answer should be 30. So if I run the code, as you can see, 5 multiplied by 6 is 30. So it is printing perfectly fine. Now as you can see, the program has stopped. So if I press enter now, the program has gone. So that means after it has printed the multiply, it has break out of the program and the program has stopped. If I run the code one more time, and this time, let's say I give percentage sign.
As you can see, percentage sign will not match with any of the character. So what I want is I want the default case to run. So it should print me error, the operand is not correct. So if I run the code and press enter, it is asking me two numbers because I have taken the input here. Right now it is not inside the switch case. So right now you will not see this error message. It will be coming here. So let me put any random numbers over here. Let's say 5 and 3. As you can see, error, the operand is not correct. So we can try one more. Let's say if we try this time division. So if I give the division symbol and let's type 625 and let's say I give 25. As you can see, 25 multiplied by 25 is 625. So it is showing me the answer. So it's very easy to understand switch cases. It is just like that. It checks for the case. If the case is valid according to the input of the case that you have given, it will go inside it. Whatever is inside the case, it will simply print out or it will do the operations as you feel. Welcome back. In the previous class, we have seen what are switch statements. Today we are starting with the introduction of loops, or the major important concept which is required in any programming language, and we are doing this in C++. So loops are very, very important. If you have no idea about loops, that's perfectly fine. Today I'm going to tell you each and everything about it. And moreover, I will even give you examples of how many types of loops are there in C++. And also I'll make separate sessions on each type so that you understand them much more clearly. So when we talk about loops, as the word suggests, it is just a circle. You can understand it that way. You can take an example of, let's say I take an example of a clock. Now clock is a very nice example of a loop. Why? Because if you see every day, if I draw a clock, let's say this is a clock, and the hour hand and the minute hand is there. Now, if it's 3 p.m. right now in the afternoon, and tomorrow also at this very moment, it will be 3 p.m. So something is going and coming, and then again going and coming, again going and coming. So this is a loop, and clock is an example of an endless loop. It does not have any end. It does not have any end. No end for this, because time doesn't stays for anyone. It doesn't have any end. So these kind of loops are there. Like these kind of loops are also there in C++. But the best thing about the loops in C++ that we can control them. We can stop them whenever we want. We can make them run till where we want. We can make them run how we want. Then what will happen is it will do some operations very fast rather than we manually doing it, which will be time consuming. And that is the reason we use loops. So if I have to give you a formal idea about loops in general, if let's say I have to write a statement, any statement, if I have to write n times means the number is not fixed. It can be, let's say 100, it can be 1000, it can be 10,000, it can be 100,000. We don't know. It can be n times. Now, if you think about writing a statement, let's say 100 times, and I'm taking the smallest number. If I write it manually also, if I type it manually, you can assume the time it will take. But when I put it in a loop, it will be done in seconds. Even if you take 100,000 times, so this also can be done in seconds depending on the compiler. So you can imagine the saving of time and resources when you're using the loops concept. So different ways are there, different methods are there, and different types are there in which we can make a loop and then we can run it different or as many times as we want. Now, when we talk about the types of loops, in C++, we have two types. One we call as an entry control loop, entry controlled, and another one is called as a exit control. So two types of loops are generally present. Now, what is this entry and exit control? Well, in entry control, what happens is generally it actually tests the condition, tests something, and then it goes inside the loop body. So it tests and then go inside the loop's body. But whereas in exit control loop, what it does is test the condition at the end of the loop body. So that is the difference. The beforehead or the entry control loop is simply that it tests the condition before it enters the loop body. Whereas over here, it tests the condition at the end of the loop body. That is, one expression, one statement is done, and then it checks for the condition. Now in C++, loops are categorized into two parts as I have shown, and they are also further subdivided. So we can say first one is there are two entry control loops and one exit control loop. The entry control loop, the first one is called as for loop, and the other one is the while loop. And then one exit control loop is the do while loop. So this is the entry control, this is also the entry control, and this is the exit control. So in the next sessions, what we're going to do is we're going to discuss each of these loops in much more detail. We'll start with the for loop and then we'll move further, and each and every loop will have a different session. Welcome back. In the previous session, we have learned about what are the types of C++ loops present, and moreover, we have understood a little bit about what are loops. Today, we're going to discuss the very first one, which is the for loop. Now, for loop is one of the most important kind of loops that are present in C++, and the reason for that you will just know it right now. So we'll discuss about it, but before that, what I will do is I will write the syntax of how do we write for loop, and then I will explain you what exactly is happening and how it's gonna like make the code much more simpler for us. So the syntax for the for loop, we write it in this way that we write for everything smaller. Then first we write initialization that we have to give. Then we have the condition. And lastly, we have the updation, curly bracket, and here inside will be the body of the for loop. So this is the general pattern of how we write a for loop. Now, what does all these things mean? So that I will let you know right. So firstly, if you see this particular syntax, first thing we have is the initialization. The initialization simply means that we will have a variable and that will initialize or start the loop. It will tell the loop from where it should start, from which point it should start. That is the basic concept of initialization. Then we have the condition. Condition simply means that it can be either true or it can be either false. Now, if it is true, then the body of the loop will run. The body of the loop, which I have written it here, this will run if this thing is true. If it is false, the loop will terminate or the loop will stop. And then we have updation. The updation or update, we can say in simple words, it will update the variable that we have used in initialization. That is, whatever variable we have used, it will update that value and it will check the condition again with the updated value. It will check again. And this process will keep on happening until and unless we get this condition to make it false and the loop will stop. That is the basic idea. So if I have to show you this, if I write the loop using a variable, I'm going to write like this. First, I will write int a equal to, let's say 0. This is a variable, suppose, and int I. If I write here for I equal to 0, I is less than equal to 7, I plus plus curly bracket. Here I'm going to write a equal to I. Simple. Now what does it mean? See over here. I have an initialization. This is the initialization. So see, I'm starting the I with 0. It is starting from the very first number, 0. Now see the condition over here. I should be less than equal to 7. That means this loop will run until and unless the I becomes greater than 7. Once it has greater than 7, the loop will terminate or the loop will stop. So that is the condition. So, and then I plus plus simply means that I equal to I plus 1. That means I'm increasing the I by 1 time. So now I is 0. Once it has run, this will happen. Then I again will become 1. Again, it will check, is 1 less than equal to 7? It is not equal to, but it is less than. So this is true. Again, this will happen. Again, it will come back. I has again been updated. Now I will become 2. Again, it will check. This process will keep on happening. When you will get 7 less than equal to 7. Yes, this is also true. It is not less, but at least it is equal to. So then this will again work. After that, when it is updated one more time and it becomes 8, now 8 is not less than or equal to 7. Now this will not happen. This thing will not happen. And the loop will stop. That is the concept. So let me show you this with the help of a program so that you get much more clear. So as you can see, I have a program over here. So this program, if you see over here, you have a for loop and int I have initialized the variable inside here also. That also you can do. Or we can write int I over there at the top and initialize the variable there also. Now see here, I is starting from 1. The variable is starting from 1 and I is less than equal to 5 and I plus plus or plus plus I. Remember, there is not much of a difference between this and this that you have learned in the operator section. Now I is less than equal to 5. This is the condition. Fine. And what I'm printing I plus 1. So now what will happen is, if I run this code, the very first thing that will happen is I is equal to 1. Fine. I is less than equal to 5. Yes, 1 is less than equal to 5. So it will print me 1 plus 1. That is 2. 2 will be printed first. Let me give the comment. 2 will be printed first. Let me write it over here. 2. After that, I will be updated. That is, it is increasing. Now I has become 2. 2 is less than 5. Yes, it is. 2 plus 1, 3. It will keep on doing that until and unless we get here 6. So it will print till 5. And that means 5 plus 1 will be 6. So that means it will print 2, 3, 4, 5, 6. Let's run the code and check. So as you can see, 2, 3, 4, 5, 6. So it's very simple to understand. You just have to know that this is initialization. That is where the loop is starting. This is the condition. That means
this loop will run until and unless this condition becomes false. And this is the updation. It can be positive, negative, multiply, divide, anything it can. But we are updating it. Updating means it is not necessary that it will be always plus. It can be minus also. Somebody can write over there I minus minus, somebody can write I divide, something, anything it can write. There is no condition that you have to put plus over there. It's not like that. You can put anything. We're just updating the I value, however we prefer it. And that is the reason it is printing. So that is the concept of for loop. Welcome back. In the previous class, we have studied about what is for loop and how for loop works. Moreover, we have seen for loop implementation in a program in C++. Today, what we're doing is we are doing while loops. Now, many people find while loop very complicated in one sense, but actually it is way too easier in order to understand it. If you understand once, then it will be very, very simple for you. When I talk about while loop, the syntax of the while loop will be way simpler than what we have done in the for loop. If I have to write the syntax of while loop, we write it in this way that we have the word while, and then we give the round bracket over here. We have the condition inside it, whatever condition we want. And then we have the curly bracket. So as you can see, we don't give the initialization and the update as we have provided in the for loop in while loop. While loop, we only put the condition. Yes, initialization and update is also required in while loop, but we give it in the outside. So the thing or the concept is same, that it is a loop. It will keep on going again and again till where we want. But while loop is a little bit different, and while loop behaves a little bit different. While loop works a little bit different from what we have learned in the for loop. Here what happens is, if the condition which is there, if I have to write this particular condition, if this condition is true, the while loop will keep on running. It will running. The time it becomes true, it will keep on running. Once the condition is false, the while loop will stop. Same basic concept that happens in for loop also. There also, if the condition is wrong or condition is false, the for loop will stop. Now the main concept or the actual concept of working of a while loop, you will understand much more better way with the program. So let me show you a very basic program using while loop so that you understand how it works. So as you can see, I have a very, very simple program over here where I have initialized a variable I to 1, which is an integer type variable, and I have made a while loop. Now see the condition very carefully that I have put the condition I less than or equal to 5. That means until and unless I becomes greater than 5, this loop will keep on running. That is the thing. So that means what is the thing that is inside the loop? We're printing the I. So basically it will keep on printing until and unless the I variable becomes more than 5. Now what it will do? We saw that I was 1, fine. So 1 came here. 1 is less than or equal to 5. Yes, it is less than 5. So it will print the I. So I'll write here using a comment 1. Then we see one update here inside the loop. Now this is the difference. We're updating it inside the loop body. So now I will become 2. Then 2 will again go, and again it will check the condition. Since the condition satisfied, 2 will also come. Then 3 will also come. 4 will also come. And lastly, 5 will also come because the equal to sign is provided. But when it becomes 6 will not come here. And this is the answer that we will get once we run this code. So let's run the code once and let's see if we get the output that I have written, which is 1, 2, 3, 4, 5. So as you can see, we are getting the correct output as 1, 2, 3, 4, 5. So you can put different ways or different conditions of how the loop will behave. Once you change the condition, the loop will completely change. So it is same like for loop. You won't see much of a difference, but theoretically, if you see, there are some differences. Those differences also we'll discuss. For now, you just understand how the while loop is working. So we have an initial variable, which is stored to some number. Then we have the condition. First, it will check the condition, and then it will go on inside the body of the loop, do whatever is inside it. Here in case it is printing the variable, and the variable will update it. Again, it will check the condition, keep on happening until the condition becomes false. Once the condition is false, program will stop. So that is the concept of while loop. Welcome back. In the previous lesson, we have studied about what is while loop and the implementation of while loop. We have also seen how while loop works using a program. Today we are discussing about do while loops. And I would request you one thing, if you have not seen the previous lesson of while loop, do check it out. Otherwise, you may find some difficulties on this particular lecture. So what is do while loop and what is the difference with while loop? It is actually, we can say this do while loop is actually a variant of while loop. So you can say it is a subsection of a while loop as well. It's just a variant. So we're just using the while loop and making a different variant and making it a do while loop. So what does it do? So what happens is, the simplest concept is it executes first once before it checks the condition. Now what does it mean? When I have a loop, my first thing is that it will check the condition and then go inside the body. Do while loop, what it does,
it will first execute. That means it will run what is inside the loop. After it has run one time, after that it will check the condition. So here the body which is there, it executes first. One time it will run, and next time after it has run one time, the next time when the loop has to run, from that moment of time it will start checking the condition. That is the only difference. And when it checks the condition, rest thing is same only, that it will check the condition. If it is true, it will work. If it is false, loop will stop. So let me explain to you much more better. You will understand it much more better with the program. So let me show you the program. So as you can see here, I have the program for do while loop. As you can see, it is a little bit different from while loop. So here, first difference you see, we have a keyword do. So do is a keyword. Remember, you cannot use do word as a variable since it is a keyword. And inside the do, as you can see, it's a curly bracket. I have two statements. That is, it is printing I variable and it is updating the I variable. I variable is equal to 1. Fine. Now, as the definition states that the do while loop, first it will execute. That means this thing should run first, one time. Fine. Then it will check the condition. One more difference you will see that in this while loop, you see a semicolon. Generally, we don't put that in loops. So this is one more difference. So that you have to remember. Now what this program will do. See, we have only one print statement inside this. Fine. So this you can think of the body and this is the loop. But here, since it's execute first one time, so if I run the code by I was 1, so the 1 will be printed. I have to not check the condition. I don't care what condition is inside here. 1 will be printed because the do will be executed and then plus 1 will also happen. That means 1 will increase. Now it will become here 2. After it has become 2, now it will check the condition. Is 2 less than or equal to 5? Yes, it is. So that means 2 will also be printed. Then 3, then 4, and then 5. 6 will not be printed because then the condition will not be satisfied. And if I run the code, this is what I should get as an output. So let's run the code. If you see over here very closely, same output we are getting. So it is very simple to understand do while loop. Just one thing you have to remember, that whatever you wrote inside the do, that will run for the very first time first. You don't have to check for the condition in the while loop for that. After that, once it has run one time, after that you have to check the condition, whatever the condition is given. And provided the condition, whatever the thing is inside the do, that will work. So that is the concept of do while loop. And that is the only difference from while loop and do. Welcome back. In the previous class, we have studied about what are do while loops and how do while loop work. But after we have done all the 3 loops that are there present in C++, we have to have a clear idea about what are the differences between all the 3 loops. So today's class will discuss about what are the differences between for, while, and do while. So I'll let you know some differences. You can note them down or you can remember them because this will be very useful for you. Now the very first difference, which is obvious, is the syntax. So that I will not mention because you already know the syntax. All are different for all the loops. So syntax is one, but that is very obvious. The most important difference between them is for loop. We know it's an entry control loop, which I have told you when we were discussing about for loop. So it is an entry control loop. And moreover, while loop is also an entry control loop. But do while is an exit control loop. So this concept you can remember. Next difference, you can think that here initialize and update are the part of the syntax. When you write the syntax of for loop, we write initialize and update in the syntax. But here it is not the case. Same goes with here also. Or we don't write the initialize or the update in the syntax. Because when you write the while, we just put the condition inside it and the curly bracket. We don't have initialize or update. And this is the syntax for the while. So that is the concept. Here, that is one more difference. One more difference is here, when you finish the loop, there is no semicolon. Same here also, no semicolon. But here, we do have one semicolon. If you have seen the previous lecture, in the while loop, at the end, we do have to give a semicolon for the do while loop. Next, if you consider for and while loop, if the first condition is false, then the control will never enter the loop. So if the first condition is false, then the control will never enter the loop. This thing is same for the while loop as well. But here, if the first condition is wrong, since it's the do while loop and which executes first time, it is not the case. It will run. Here, if the first condition is also wrong, still it will run or it will go inside the body, because since it's a do while loop, do always runs the first time, even if we don't have to see for the condition also for that. So these are mainly some differences between for loop and moreover while and do while. Here we have just understand certain things, that which is entry control loop, which is exit control loop, whether initialize and update is part of the syntax or not.
So for the for loop, yes, it is, but not in the case of while and do while. And we don't have any semicolon at the end. Okay, we do have inside the syntax, but not at the end. I'm talking about the end here. So for loop, it doesn't have any semicolon at the end, and while loop, it doesn't have, but in do while we do have one. And one more difference is the first condition, if it is wrong, while loop and for loop will not work, but do while loop definitely will work. So that is, you can think of the basic difference. There is no like a complete difference between all three, because you can think of like this, that do while loop is made from while loop only. So the concept has come from there only. So you will not see very much of a difference. But if somebody asks you some differences, you can say these 4 points together so that it clears all the differences. If there is any differences, like for example, in certain cases, you will not find any difference between for and while, but in certain cases, you will find differences between for and do while. So different things are there. So these are some differences which you can find among all the 3 loops which you have learned. Welcome back. In the previous class, we have seen what are the differences between all the loops that are present in C++. Today, we're starting a completely new topic, which we called as arrays. Now, what are arrays and how do they work in C++? Moreover, what are the applications of arrays? Why do we need it? Everything I'll tell you in this. So this will be like an introduction to arrays and how arrays perform in C++. So in the basic sense, if I have to say simply, you can think like array is simply just a variable. All arrays are kind of variables, but there is a difference. The variable that we have learned, like for example, we write int a equal to 1. Here a is a variable. Fine. Array works a little bit differently. What does it mean? Array is a variable which stores multiple value at once. So let's say, for example, you have 30 students in a class and you want to store a record of all of the students. So you can use the help of arrays. So if, let's say, as I give the example of 30 students, so how do we write is, we will write, let's say we want to store the, let's say the marks of all the 30 students. So we're going to write float, and I'm going to give a name to the array marks. And once we have done that, we give a round bracket like this, and I will write 30 inside it and give a semicolon. So in this array, the name of the array is marks, which is the name of the variable. So you can relate to a over here. Float is the data type. Here int was the data type. And 30 is the amount of students that can be present in this array. That is the maximum value of 30, which this array can have. Now, how do we declare an array? The very first thing we do is we write the data type, as I have just now wrote data type. Then we write the name of the array, just like a variable, any name you can give. Just you have to make sure you know the rules of the variables that you have learned before. And then inside the bracket here, the array's size will come, whatever size we want. So array size will come. And then we give the semicolon at the end. So this is the basic declaration of an array. If I need to write an example for this, we will write here, let's say int a7. This is an example of an declaration of an array. Now, one very common question that we get is, if I have an array, let's say if we have a is the name of an array, and we generally put numbers like this. So if I write 4, 1, 0, 2, 11, 17, 21, and 22. Suppose this is an array. This is also we can declare, like initialize and declare. So int a is the name of the array. And here we have all the numbers or the values present here. So we can give the round bracket here, and 1, 2, 3, 4, 5, 6, 7, 8. So 8 numbers are there. So I have declared it and I have also initialized it. So 8 numbers are there. Now the question is that our job is to find the numbers. That is, suppose I want to access this 11. How will I do it? Because when we have a simple variable, int a is equal to 1, I can directly find the 1. There's no problem with that. I can simply just write a anywhere and it will be equal to 1. But here, if I write a only, it will not make any sense because it has all these numbers and I want only the 11. So what can I do for that? For this purpose, we have a concept in array that we called as index. Now, what is this? Let me give you a very nice example for you. Imagine you want to go to your friend's home. So this is your friend's home, for example, and this is your home, for example. Now, you don't know the actual address of your friend. So what will you do? You will ask him that what are the landmarks present on your, near your home, or maybe a famous place present near your home. That way you can move there. Similarly, I don't know whether where 11 is. How can I access it? But I do know the address of 11. Address. So if you know the address, you can easily get the value because I have to first go to the address before I access the value. So this address is referred as index in arrays. So basically, if I have to write this, so suppose you can think like this, that if I have the array int 8 equal to all the numbers that were present, let me write again some random numbers. Fine. Now here I wanted to access 11. How to access it? What happens is here on the top we write the index, that is the address of the array, and we start generally, that is the address is started generally with 0, then 1, then 2, 3, 4, 5, 6, 7, 8. This is how the index follows. Now you have to be very clear about this, that this is not the exact memory location present. Like for example, if you have your RAM inside your computer, 0 is not located in the tooth location. It is not like that. It will be some hexadecimal memory location. It can be anything. But for our simplicity, we consider them as this way: 0, 1, 2, 3, 4. Now I know that in this array, 11 is present on the 4th index. So if I write here A4, this should give me 11. So this number which I'm writing, the size of the array, that is actually also the index of the array. That gives the index. That is, if I'm going to this 4 in the array, it should return me the 11 because 11 is present in that particular address. Now suppose if I have this particular array, here I have, let's say, the actual address here. Now over here, if we consider this address, the very first address, let's take, I'm taking here 2120. Let's take this the very first address for this particular index. Any idea what will be the next address? We will write here 2124, not 2121. Why? Because as you can see, we are using an int data type. And we know that int data type take 4 bytes of memory. So if the first address is 2120, the next address we will add the 4, so it will be 2124. So that is how the address follows. But for simplicity, we write like this, which is the index. And this is what we call as an array initialization. So here we're putting all the numbers. Now one thing is possible over here. If I write int a, let's say 7, and I'm initializing it to some values, let's say 40, 41, 42, 43. Now this array is also correct. Even if the maximum amount is 7, I have only put 4 numbers, index 0, 1, 2, 3. So this can be also possible. Just one thing you have to remember here is that when you will run this code in the compiler, what it will see is it will see it like this. It will write 40, 41, 42, 43, and it has 3 numbers less, so it will write 0 over there. This is how it will put, which is completely empty. So in one case, you only have these 4 numbers only. This doesn't make much of a sense because that is given by the compiler. It has put 0. It can be any random number also, but generally it is 0 only. So you will get much more idea about arrays using a program. So let me show you a program of how to implement arrays. So as you can see, I have a very basic array program over here where I have a variable called as numbers, that is an array variable, and it has 5 as the size of the array. And as you can see, I have 5 elements over here, or 5 numbers over here: 7, 5, 6, 12, 35. Index will be 0, 1, 2, 3, 4. Now I'm printing the numbers. Now how do I print the numbers? As you can see, I'm using a for loop over here because I have to go index by index. So this I which is there, this I is coming over here. So it is going with the index. That means if I write for I less than 5 and I plus plus, and I'm printing the number. So what this do is, let me show you in the whiteboard. So the array was written here as numbers 5. The numbers were written where 7, 5, 6, 12, and 35. Now see how the for loop is working. So I have for I equal to 0. I is less than equal to 5. I plus plus, or plus plus I. Both the same. Now see what happens. When I is 0, that means it is going to the numbers 0. That means I'm referring to the 0th index. What is the 0th index? 7. So at first when the loop runs, 7 will be printed. Then when I becomes 1, numbers 1, the next value 5. This way all the numbers will be printed until we reach 35. So that way it is going. So I will be 2, I will be 3, I will be 4. Now this equal to won't come here because we have to go only till 4. That way this array will work. So if I run that piece of code which I had, it should print me all the numbers. That is 7, 5, 6, 12, 35. So let's run the code. So as you can see, 7, 5, 6, and 35. 6, 12, 35. So it is giving me the perfect answer. So basically we're going through indexes. That is 0, 1, 2, 3, 4. And here if you see, I is starting with 0. It is going till 5. This I value will keep on coming here. 0 will come, 7 will be printed, 1 will come, 5, 2, 6, 3, 12, 4, 35. So very basic way to understand array. Welcome back. In the previous lesson, we have seen the introduction of arrays. Today, we're doing a bit of a theory lesson to find all the properties of arrays. Now, this is a very important lesson in order to understand what are the properties that are there in arrays for which we are learning arrays. Like you will understand what are the importance of arrays. Moreover, why do we need to use them in C++? Now, there are a couple of important properties which we found out in arrays. The very first one which I have to refer is that arrays are homogeneous in nature. Now, what does this word homogeneous mean? So if I have to give a clear idea about it, is that if you see the previous lesson where I wrote the array in, let's say A is a name of array, I have 6 elements here, and let's write 40, 39, 60, 51, 71. 1, 2, 3, 4, 5, 73. So here I have 6 elements over here. Can you see one similarity over this, that all are integer type numbers? That means they are of homogeneous. You can use one array at a time. You can make one array at a time with similar data type only. Like you cannot put a float number in between, or you cannot put a double number in between, or something like that. You cannot put a string in between. So if you're doing an int array, everything should be integers. You cannot put anything else. So that is the first property, that they are homogeneous in nature. The next property for arrays are that they store the data in continuous memory location. Continuous memory locations. Now, what does this mean? If I have to talk about an array which I wrote, let's say int 6, if I have to draw like a box, like a memory box, something like this, if I draw 1, 2, 3, 4, 5 and 6, 1, 2, 3, 4, 5, 6, 7. So let's write 7 here. Fine. So let's write some numbers here. Let's say 6, 1, 0, 2, 3, 11, 40. If I have to write the address, that is the locations for this. So how will I write? If the very first address is starting with 1000, the next one, since it is an int type data type, it will be 1004, then 1008, 1012, 1016, 1020 and 1024, because int type data type takes 4 bytes of memory. So since it's a continuous memory location, so after that, since it's an int type, the next space or the next address will be +4 of the previous address. So that is why this is how they are stored. If let's say I had string or character, let's take character, then it will be continuous 1 byte. So after 1000 will be 1001, then 2, then 3 for characters. So data type plays a crucial role in the address of where the values are stored. So that is the second property for arrays. The third property for arrays are that index of the array always starts with 0. Always starts with 0. So no matter which data type of array you're making or what kind of array you're making, always every single array's index will start with a 0. For example, if I have an array over here, 1, 2, 3, 4, 5, 6, 7, 8, 1, 0, 11, 12, and 40. So this will be 0, 1, 2, 3, 4, 5, and 6. So no matter whatever array I'm doing, I have to start with the index starting with 0 only. So that is the rule for the array, or that is the one more property for the array. The next property for the array, you can consider this as a disadvantage, that arrays are of fixed size. Like if you have made an array and you have fixed the size, let's say if I write int a is equal to 7, I cannot change the size of this array. It will be 7 only. I can only put maximum up to 7 elements. So this is one disadvantage which you can see. And we users has to declare, like we users has to mention the size when we are declaring it, and it will be fixed. You cannot change it afterwards. Cannot change the size. Fifth property which will be for the array would be arrays can be multi-dimensional. Now what does this thing means? Till now the arrays that you have seen even in the program and the arrays which I'm making, they are all one-dimensional arrays. It's just one single dimension. But whereas you will even learn those, maybe after 2 more sessions, you will learn about multi-dimensional arrays. So you can simply take this in the format that it's an array of tabular form. It's like a table where it will have rows and columns, and there we store all the numbers. So it will be same as homogeneous arrays only. So all int type data type will be there, and it will be homogeneous, but it will be of tabular form. It will have rows, it will have columns. We'll discuss more about multidimensional array when you will have that lesson. So one lesson is there only for multidimensional arrays. There you will understand it much more better. As a property, you can remember that array can be multidimensional as well. So these are some properties of arrays. Welcome back. In the previous class, we have learned about what are the properties present in array and why we choose arrays. What are the advantages of using arrays in C++? Today, we're going to learn about a bit of operations with arrays. Now with arrays, you can do a lot of operations. I'll show you the most basic simple one. Like generally what you can do is you can add arrays, you can subtract arrays, you can multiply them, and you can also divide them. These are the 4 basic array operations that you can do, which I will show you with the program as well. There are other operations also which you can do that you will learn in the future. Like for example, you can do searching, you can do sorting, finding maximum, finding minimum, different kind of operations you can do. These are all different kind of operations of how you traverse the array and when you do such things. So these are just few examples of what kind of operations you can do. Since you are learning it for the very first time, if I'm considering that you as a beginner, I will show you only the basic how you can do add, subtract, multiply, and divide. In the future classes, you will learn about searching, sorting, finding maximum, minimum, all those things that will come with the help of an array. So let's see a program to understand addition, subtraction, multiplication, and division using arrays. So as you can see here, I have a program where what I have did is I have declared some variables, size, I, array1, array2. Then I have one int data type where I have 3 arrays here where I have put addition, subtraction, multiplication, and mod. And one float variable I have taken, which is div. This is also an array which can have maximum of 10 elements. Then I took the input of the size, whatever size of array I want, and then I have taken the input. So as you can see, I have entered the input here for the array 1. Next, I did the same thing for the array 2. So I have now 2 arrays which are having some elements inside it. Then what I did is, as you can see, it's so basic that we just have to put the symbol. So here we're doing addition, here we're doing subtraction, then we are doing multiplication, then we are doing division, and lastly we're finding also the mod. This is one extra modulus or mod which will give us, like, it will divide them and it will give us the remainder. It will store it in a new array. Now the question is here that is it possible like we get the answer just by simply doing or simply putting the symbols? Yes, it is. Array is just like when you're adding 2 variables or multiplying 2 variables, dividing 2 variables. It's just like that. You just have to put it into the for loop and the variable which is iterating through the array. So here the I variable is iterating, so I have put the I variable on both the cases. Now simply what I'm doing is I'm simply printing all the arrays and we will see what answer it gives. So let's run the code and see what do we have. So over here, first and foremost, it is asking me the size of the array, that is the very first array size. So let's put 5 elements over here and press enter. So first elements I have to put, so 4, 1, 0, 7, 8, and next array size, let's give 5 again, 1, 7, 15, 4. As you can see, it is giving me the answer of all. So addition we have, subtraction we have, multiplication, division, and the mod. So you can calculate them. Let's take one random example. Let's take here the last element, 8 and 4. So if you see, 8 and 4 addition is 12, subtraction is 4, if you multiply it is 32, if you divide it's 2, the remainder will be 0. So it is giving us the correct answer, and since I'm printing it in this way, as you can see, using /t and /n, so it's giving me in a proper tabular format. So these kind of operations you can do. Moreover, there are other operations also which I have told you in the starting, that you can search an element in the array. You can do sorting, like for example, if the array is, let's say if you have an 4 element array, as you can see here, 1, 7, 15 and 4, these are not sorted, these are randomly. So I can sort them, like I can put from lower to higher or from higher to lower. So I can sort them however I feel like. Then we have operations like finding the maximum. Here the maximum is 15, for example. Then finding the minimum is a 1. So these kind of operations you can do, which you will learn. Welcome back. In the previous class, we have seen about what are the basic operations that you can do in an array. Today, we're going one step further and we're going to learn multi-dimensional arrays. Till now, whatever arrays you're learning, those are all one-dimensional arrays. Today, we're going to do 2-dimensional arrays and 3-dimensional arrays. Now what are these things? So generally you can think like this, that when we call about a 2D array, you can think like this, that it is a table form. It's just a table. Table means what? It will have a row, it will have a column. That is the only difference. When we have a 1D array, it was just like one straight line where it has some different random elements. But here, over here, if we see, when it is a table format, it will be something like this. So we can have a table format like this, and it can have some elements into it. So it can be any random elements, but it will be of a table format. Now, when we have to initialize a 2D array, we simply write in A, let's say the name of the array, 2 and 3, for example. This is a declaration. I can give a semicolon here and it will be declared. But since we're initializing, we're just going to give the equal to sign over here. And let's write 2, 4, 1, 0, 7, 6, and give a semicolon. Now, this method generally is not preferred because we have a better way of initialization. If I have to write the same array in a better format, I'm just going to write 2, 3. Here I'm going to give 2 brackets like this. I'm going to write 2, 4, 1, 0, 7, 6. So now as you can see here, we have written 2 and 3. So that means this array has 2 rows and 3 columns. So as you can see, this is 1 row, this is 2 row, and 1, 2, 3 columns. So 2 rows and 3 columns. That is how we see. If you want to see this in a block diagram, so we're going to make like this. Here I'm going to write 2, 4, 1, and then 0, 7, 6. So this is, you can see row 1, this is row 2, this is C1, C2, C3. 2 rows, 3 columns. This is what we call as a 2-dimensional array. Now when we talk about a 3-dimensional array, firstly we write int, I write A. Let's write 2, 3, 4. The way to initialize a 3-dimensional array is, we're just going to give a bracket like this. Since the array is going to be a very bigger one, so So we're going to write the first curly bracket here, and then we're going to give one more curly bracket. I'm going to write some elements. Let's write 3, 4, 2, 3, for example. And let's write 0, -3, 9, 11, and we're gonna have again 23, 12, 23, suppose 2. So this is one single row, as you can see. This way, when we have mentioned it, we're gonna give the curly bracket again, and we can mention again the other values for it. This way, I'm just gonna do it until it is over. But the main question is that how do we use these two arrays? Generally, you're gonna have two-dimensional array more than compared to three-dimensional arrays. So for that, let me show you a program for both of them. That is a two-dimensional array, a three-dimensional array, how to take inputs and how to display all the elements. So let's see those in a program. So as you can see here, I have a program where I have tried to display a two-dimensional array. What I did, as you can see, I have declared an array over here, which is a two-dimensional, 2 rows, 3 columns. I have entered any 6 numbers. Why? How do you know how many numbers it will be? Because you just have to multiply this with this. I have told you this in one previous lesson. Then I have taken the input. Here I'm using 2 loops. First loop is for the row. Second loop is for the column. That you have to remember. Then I'm taking the input just like how we normally do. Now here if you see, since I'm using 2 loops here, so 2 iterators are there. One iterator will be for the row. One iterator will be for the column. So as you can see here, when I'm printing the array, the first iterator is I, second iterator is j. This way I can understand that this will be row and this will be column. Now let's try to run this and see what happens. So if I run the code, it's going to ask me any 6 numbers. So let's type any random 6 numbers, 5, 6, 1, 2, 9, and 0. So as you can see, it is printing me all the random 6 numbers which I have given. And moreover, it is even giving me the indexes. So 0, 0, that is the very first index for both the rows and columns. The first row is 0, second column is 0. First row is 0, column is 1, first row is 0, column is 2. So this is for the first row, and then these are for the different columns. So it has 2 rows, that is 0, 0, and 1, 1, and 3 columns, 0, 1, 2, 0, 1, 2. That way it is storing all the values. So it's just like a tabular. But when we compare this with a 3-dimensional array, let's see that as well. So here I have a 3-dimensional array. As you can see, it has 2, 3, 2. Here, if you see 1, 2, 3, 4, 5, 6. You multiply these two, you will get 6, and it has certain elements. Now here, as you may have figured out that we have to use 3 loops because it's a 3-dimensional array and we are printing it. So as you can see, it will be coming like test, which is the name of the array, I, J, K. So the basic format is same only. There's not much of a difference between 2-dimensional and 3-dimensional. Just one extra loop will come over here. So since I'm not taking here input, I'm just displaying the array directly. So if I run the code, it should display me the array. As you can see, all the elements present in this array has been displayed. So it's from 1 to 12. And this format is also the same one only, just here one extra loop is getting added. So that is the thing you have to understand about 2-dimensional array and 3-dimensional array. 2-dimensional array you will use a lot when you compare with a 3-dimensional array. So 2-dimensional array is the most important. Welcome back. In the previous class, we have studied about what is multi-dimensional arrays. We have seen the implementation of that and we have understood why it is required. Today, we're starting one important topic, which is introduction to functions. So today we're going to start about functions in C++. I'm going to tell you what are functions, what are the basic things present in function, how to implement in a program, and why do we need it. So now this is one of the most important topics, so that I'm giving 3 stars over here. The reason why it is important is that functions have certain advantages. Different kind of advantages are there. But before we talk about advantages, we have to know what is a function. If you have never done programming before, you may not know what is a function. So I'll give you a very basic definition about function. How can you understand function? So it's a block of code. It's a block of code that performs a specific task. So this you can say is one basic definition of what we can say a function is. Function is simply a block of code which performs a specific task. It can be anything, whatever you desire to do with that particular function. Now, when we talk about functions in C++, there are of 2 types. One we have that we call as a standard library function, and the another one which we have is called as the user-defined function. Standard library function and a user-defined function. Now, what are these things? Very simple to understand. These are predefined by C++. So they're already present in C++, and these are created by the user. That is the basic difference between these two. That is a standard library function and the user-defined function. Now, you have already done standard library function. A lot of them we have done, like for example, we have used the maths functions like pow we have used before. We have used sqrt before. So these are all predefined functions. They're already present. Yes, somebody has made these functions, but they're already present in C++. You have not made this function, or I have not made this function. You're just simply using them in order to get some output. But when it comes to user-defined function, they are completely made by ourselves. So standard library function, it's not that important because you just have to remember it, but user defined you have to know because you have to make the function on your own. So what is the procedure for that? That I will show you. So when we talk about user defined functions, as the name suggests, it is defined by the user. Here what happens is the function which is there, we give the function a particular name. It can be any name, but it should match the task of the function. What does it mean? For example, if your function is to add two numbers, so I'm going to write the function as add, but this is not important. It is completely optional. The reason we give add is because if somebody else sees your program, he must understand that what this function will do. If you see the word add, he will at least understand that yes, this function is adding something. You can write any name. Like if, for example, if I write sum and then write the function, that is also fine. There's no problem with that. This thing, the thing I've written at the bottom, this is completely optional. So I'm going to write OP over here. It's optional. And the biggest thing is that what is the syntax of a function? Like how do we define or how do we write a function? There are two parts when we have to make a function. First, we have to define it and then we have to call it. First, we'll do the define part. So what is define or definition is we have to write the function. So first we will write is that a return type, function name, round bracket, curly brackets, and inside here the body will come. So this is like the very basic syntax of a function. Here we have other things also, like inside this bracket we do have parameters, but that we are not doing right now. We're just doing a normal simple function without any parameters or arguments. Now, what is this? What exactly we have done? If I have to write this as an exact function, this is syntax. If I have to write this, if I write void, this is a return type. Void means what? It is empty. So when something is empty, it will not return anything. It will not return anything. It's void. It's completely empty. So I'm going to write void. Let's say hello and give a round bracket like this. And inside here, I'm going to write cout, hi there. This is a function. Very simple one. Here, you can see the name of the function is hello. Return type is void. The body of this function is this. So that is how we write a simple basic function. But if you run this piece of code, still it will not work because here we are simply defining the function. We have not yet called the function. It simply means that you have made a car, but you have not driven it yet. So you have to drive the car, right? So we have just made the function yet. We have not called the function so that the function works. So this is a function which is defined. We have to call it, then only it will run. Now what does calling of the function means? Calling of the function means is I have this function. If you see the function name is hello, fine. So what I'm going to do is in the program itself, I'm going to write int main. That is our main function. Inside here, I'm just have to write the name of the function, semicolon, then return 0. So as you can see here, I am calling the function. Calling is happening here. So once I call the function, then it will run. That is whatever is inside the body, it will work properly fine. So what does it happen is, if I have to show you in a better way, whenever I have mentioned here the word hello, this thing will directly go to the top, the function, whatever is there inside it, that is cout, hi there, will be printed over here. So it will directly come over here and then it will print it to the screen. So let's see this thing with a program so that you understand it much more better. So here I have a program. As you can see, it's a very simple program. My function name is void greet. As you can see, we write the function outside the main function. So we write it outside the main function. So greet is the name of the function. Void is a return type. Inside here, I'm just simply printing something. This part is the definition of the function. Let's see what we have done inside the main function. Inside the main function, I have called the function. So here I am on this part, I'm calling the function, and here we are defining. That is the difference. Here we're defining, here we're calling. If I run the code, it should print hello there. As you can see, it is printing perfectly fine. So what exactly is happening is, when I'm running the code, remember one thing, the code starts with the main function. So it will ignore this first. Once it runs the main function, it saw one calling of a function. So it will find this. Where it is, it's here. What it's doing, it's simply printing this line. So it will simply print that line, then return 0, close. As simple as that. So that is how function works and the basics of functions. Welcome back. In the previous lesson, we have seen how function works and we have seen an introduction to function. Moreover, we have seen the implementation of function in a program. Today, we're moving one step forward. We'll do function parameters. This will continue from the previous lesson only. It is related to function only. So in the previous lesson, I have given you the introduction to function. Today we'll do a little bit more advanced part if you compare with the previous one, function parameters. Now what is this? So we can declare or we can define function with parameters. What does it mean? A parameter is simply a value. It is just a value that we pass to the function. What does it mean? That means I have to run a function. That is, a function will do something, but it should do according to the value that I'm giving to the function. Let's say I have a function that will add two numbers. So I have to pass these two numbers to the function. How will I do it? Using parameters. That is the concept. So let's see one example for it. If I write one function here, if I write, let's say void print, the name of the function is print, and I'm going to write here int and start a bracket, and I'm simply just going to print n over here. So this is a function here. This is the return type. I've told you the previous class name of the function. This is the parameter. In some cases, we also call them as arguments. This is the parameter. Here, n is the value that we will pass when we call the function. So how will you call this function? If I write here int main and I give round brackets here, if I write here print and I write 5 inside it and semicolon, then what will happen is this 5 from here, it will come here on this end, because that is what is referring. So once 5 came here, 5 will be here also, and that is, it will print 5. So we are simply passing this particular 5, that is the value. It is not like important to give 5 here only, it can be anything. Just one thing you have to remember, that what data type you're using, since it is int, it will only be int only. If by chance you give 5.5, then it will take only 5, since it is int. So that you have to remember. Whatever data you're passing, make sure you know the data type. Looking at that data type only, you have to put a value that you want to pass to the function, and that will be printed. It is not like it will only be printed. You can do different operations also, like add, subtract, that I will show you as well in the program. So let's see this in a program of how does it work. So here I have a program, and this is what function is there. And here we have a function where we have the name of the function as display num. Here I have two parameters. As you can see, one is an integer type n1 and one is a float type n2, and both are separated with commas. So there is no limitation of how many parameters you want to write. Just separate them with the comma, make sure the data type is correct. What I'm doing, printing both the numbers. So whatever number we're gonna pass, I'm printing it. Then what I did in the int main function, I made two more variables, that is num1 and num2, and I've assigned two values, that is 5 and 5.5. Fine. That now I call the function. This is how we did it. We call the function in the previous class as well. But here I'm passing these two variables, that is num1 and num2. What is num1? 5 and 5.5. So 5 will go here to this n1 and 5.5 will go here n. That means if I run this code, it will be printing the integer number is 5, the double number is 5.5. So let's run the code and see whether it's working. So as you can see, the integer number is 5, the double number is 5.5. So it's working perfectly fine. So very basic thing to understand is we just have some parameters, and when we are calling the function, we just have to pass something to the parameter, and according to that parameter only the function will work. That is the basics about how parameters works. You can do different kind of operations here also, like addition, subtraction, multiplication, division, so many things you can do. Just I'm giving a basic idea about how parameters work and how it is passed when you call the function. Welcome back. In the previous class, we have studied about functions with parameters. Today, we are doing something which we call as a function prototype. Now, what is this and how does it work? Generally, what happens is, you have learned in the previous class as well, when we have to define a function, let's say I have to define a function, we have to define the function before we call it. That means, if for example, if I have certain lines of code, and let's say, for example, I'm calling the function over here. So here's the function call. I have to define it somewhere here before the call of the function. But when it comes to function prototype, we can define a function even after calling the function as well. That is done using the concept of function prototype. So what is it? How does it work? Let's understand. So let's understand this with an example. If I write void addition, and I'm going to pass, let's say int, int. After that, I'm going to write my main function, and I'm going to call the function over here, which is addition. And let's pass 7,3, return 0. Then I'm going to define the function void addition. I'm going to write, let's say int a, int b. And here I'm going to print a plus b. Now over here, if you see, the compiler has the information that here we have using functions and its parameters. Now here, if you see this particular line, this is the function prototype. So here, as you can see, that we can use the code to call the function before the function has defined, as you can see over here. So we're calling the function here, but we're defining it afterwards. So that means using a function prototype, which is this one, I can call the function before I'm defining that particular function. Now let's understand this with a program so that you can understand it much more better. So here I have a program, and as you can see, I have tried to do the same thing only, just a little bit difference. Firstly, I have made the function prototype. So here I'm going to give a comment and write FP over here in short form function prototype. So here I have an add function, which has two data types passed to it. Then I have a main function where I have made a variable sum, and that sum is equal to the calling of the function. It's the same, and I'm passing two values to it. And then it's simply printing the sum, which is stored over here. So that means 178 will be stored in the sum, and I'm printing it. But till now the function is not yet defined. So out of the main function, I've written int add, same name of the function, int a and int b, two parameters have been passed, and I'm returning a plus b. This return will come back to this add. Whatever the answer is, it will store in the sum and will print it. So if I run the code, I should get 178 as an answer. So as you can see, it's working perfectly fine. So it's very simple to understand function prototype is we simply make a prototype in order for us to call the function before we even define it. So it's that simple to understand, and that is the whole concept of function prototype. Welcome back. In the previous class, we have did what is function prototype, we have seen a program out of it and understand how it works. Today, we are doing a very important topic, which is called as recursion. This is an extremely important topic which you have to understand, but I would recommend you, if you have not seen any of my lectures in functions, do watch them and then come back over here, because without function, it will be difficult for you to understand recursion. So make sure you do that. So let's talk about recursion and what is it, how does it work? Well, if I have to give you a very simple idea about recursion is, we simply say that function calling itself. Now you may not understand this statement, which I have written here, function calling itself. What does it mean? Simply, we have a function and that function calls the same function. We call it as a recursion. So it's like, if I have to show you with a diagram, it will be something like this. Let's say I have a function void r, and inside here I have the same function r and r again. So as you can see, same function is calling itself inside it. This process, we call it as recursion. This process will continue happening until the condition becomes false. It will keep on happening. That is, the recursion will keep on happening until the condition becomes false. Now there can be a possibility that we can get infinite recursion. That means the process will keep on going on. For that, there are different ways are there. You can use if else loops and all those things. But yes, you can even get infinite recursion. So that can be also a possibility. You can understand recursion much more better with a program. So let me show you a program and I'll explain you what exactly is happening. So over here I have a program where it is finding the factorial of a number. Our main important thing is only just line number 19. That is the most important thing, but still I'll explain the whole program. First, as you can see, function prototype we have learned in the previous class. So factorial is a function, int is a data type I have passed to it. In the main function, two variables are there, int n and result. Taking the input, result is storing the factorial n. This n I'm passing it to the function. So I'm assuming I don't know anything inside the function definition. Then I'm simply printing the factorial of n equal to result. Fine. Now let's go back to the function definition. So the function definition is, I'm passing a parameter int n. Now you see here very carefully, if the n, that is the input that you have given, is greater than 1, I'm returning n multiplied by same function called minus 1. So what does it mean? What does this thing means is, if let's say if you don't know what is factorial of a number, if let's say I write 5 factorial, we write like this, or you can write like this as well. The same thing goes like this, 5 multiplied by 4 multiplied by 3 multiplied by 2 until we reach the 1. So the answer is 120. If let's say you have 3 factorial, so 3 multiplied by 2 multiplied by 1 will get 6. The same thing. So what exactly is happening is, I'm returning what? I'm returning n multiplied by same function n minus 1. What does it mean? If let's say I have given 5 as input, so what will happen is, I have 5 here, then 5 multiplied by function of 5 minus 1. That means 5 multiplied by function of 4. Now this 4 will again go to the function. It will check if your n is greater than 1, then again you have to write n multiplied by factorial of n minus 1. Now since our 4 is greater than 1, so it will happen like this. 4 minus 1. So it will be 5 multiplied by 4 multiplied by 3 factorial. And again the process will continue. 3 will come here, then factorial of 2. Again process will continue. 3. And lastly, when it is 1, it is given in the statement, if n is equal to 1, it will return 1. So that means this thing will give us 1. So at last we'll get 5 into 4 into 3 into 2 into 1. That is 120. So that is the concept. So we're calling the same function over and over again until we get the desired result. So this is the concept of factorial. So factorial we'll get in maths also. Same thing we're applying over here. This you can do using normal function or using recursion. Now as you can see over here in the program, that else return 1. That means when n becomes or close to 1, then we'll return 1 over there when this condition is false, if n is not equal to 1. Now here, if one thing is to be marked out, you have entered positive number, because factorial of a number does not exist for negative numbers. So that you have to mark it, that negative numbers cannot have factorials, only positive numbers. So that's why I have not put the condition that if n is equal to 1. I have just written else n is equal to 1, because I am asking the user, you have to put only positive integers. If you put negative integers, it will not work. So that is the concept. That is how factorial works. Most important line is line number 19. I'm simply calling the function again and again. You can do other programs also using factorial. Like here, we don't have to use the concept of loops. So the same program I could have done using loops also. But here, since I'm using recursion, I don't need the concept of loops. I'm simply calling over the function again and again. So you can see it's a kind of like a loop only, but here it's looping of functions. Same function. Welcome back. In the previous class, we have done recursion. We have seen the introduction to recursion, and we have also seen how using recursion you can make programs even simpler. And other way is how recursion is related with functions and how it is important. Today, we'll do pointers in C++. So I'm going to tell you what are pointers and why do we need in C++ and what are the important points that you have to remember when you're using pointers in a program. So when we talk about pointers in C++, the only thing that you have to know is that they are simply variables. But there is some difference. Pointers are variables which store memory address of other variables. That means if I have, let's say, a variable x and I have a pointer y, address of this variable will be stored by this pointer. That is the job of pointer. Since pointer is also storing something, whether it's a value or an address, it is also a variable. But it is not storing something of its own. It is storing the memory address of other variables. So that can be a formal definition of pointers. Now, before that, you have to know about what is address and how does it work. So when we talk about address in C++, the best way to understand is you have to know the and sign. You have learned this as an operator in the previous class, but right now you can understand this that, for example, if I have a variable, let's say int a equal to 1, I know the value of this variable, that is 1, but I don't know the address. So how will I find the address? I'll write and a. So this will give me the address or the memory address of this particular variable and what is the address of it. So you can do is you can write this line in a program int a, and if you print the and of a, it will give you the memory location. It will be some hexadecimal numbers, random numbers. It can be anything like probably 0x0118, something like that. It will be an hexadecimal random number, but that will give you the address. So if somebody asks you that how to find the address of a variable, you just use that particular sign. Now here you have to remember one thing. Since it is an int data type, I have told you this in the previous lessons as well, that it will be differ by 4 bytes. Since int take 4 bytes of memory. For example, if the very first address, let's say I have two variables here, int a is equal to 2 is also there, sorry, b is equal to 2 is also there, then the first address of a would be, let's say it's 0x011. So for the next address would be 0x015, because we have to go differ by 4. So plus 4 will happen, so it will be 5. So this way it will differ by 4 depending on which data type you are using. So if you're using float, it will be 4 again. If you're using double, it will go plus 8. Now the big question is, since we're doing pointers, how do we declare a point? So that we have to understand. So when it comes to declaration of pointer, if I have to declare a pointer, the best way to do it is we write int star x. So this is how we declare. Here, this star is only which makes this variable as a pointer. Now, there are one more way which you will see generally. We can write this same way as int star and then give a space and write x. Both are same way. Whichever you prefer, you can use. I do prefer to put the star with the x. Some people prefer put the star with the data type. It doesn't make much of a difference. Both are same on. One thing you have to remember is the pointer over here, it behaves same as a variable. For example, if I have to declare a pointer in a normal variable, I can write like this. Let's say int x, int star b, where b is a pointer, comma p. Now over here, if you see, the first variable is a pointer, second is a normal variable. So we can write directly like this also. There is no difference in how you're declaring it. Just you have to give the start of which variable you want to make as a pointer. Now let's understand that how pointers actually gives the address of other variables. So if I write here, let's say int star a, comma b. Now here I have a pointer variable and I have a normal variable. If I write over here in the next line, b is equal to, let's say 7, b is equal to 7. So I have hard coding a value to b. So b is 7. Fine. Next, what I will write is if I write a and b. Now this is important. Here what happened, whatever the address of b is there, it will be stored in the a. You cannot do this with a normal variable. That's why we're using it as a pointer. Since b is a pointer variable, I can store the address of b onto a. And that was the definition that we have did about pointers, that it stores the memory location or the memory address of other variables. So b is another variable, a is a pointer. I'm using the and sign and a is storing the address of b over here. Now, if I need the value, I have to use the star. That means I do have the address of b, but if I write here star a and I print this thing, this will give me the value of b, which is 7. So it is not like I only have the address. Like it is just like this, that you can understand this, that if you have an address of a person, you can go to that address and you can meet that person, right? So if the address, you have the address, so it is not difficult for us to get the value for it because we know where it is stored. I just have to go inside it and I have to fetch the value. How will I go inside it? I have to use the star. So if I print using the star, I will get the value inside it, whatever value it is. Now over here, if you see, whenever we use a star with a pointer, we call it as a word. There's a word, we call it as a dereference operator. The star which is there, we call it as a dereference operator. What does it do is, it basically points to the value. Since I already have the address, I need the value. So this star or the dereference operator helps us to point to the value which is there on that address and it will fetch it out if I print it. Now to understand all these concepts, we have to understand with the program. So let me show you a program of how pointer works. So over here I have a program and it's a very simple program of pointer. Here, if you see, I have a variable which is storing a value 5, fine, the int data type. Then I have a pointer over here. Next line, what I'm doing is I am taking the address of var, that is wherever 5 is stored, and I'm pushing it in the pointer variable. Then I'm printing the variable. So this I know it will print as 5, simple. Address of the variable, so it will be any hexadecimal number. We're not sure about it. When we'll run the code, we'll see what random hexadecimal number comes. That is the memory location of this particular variable, which is where it is stored. Then I'm printing out simply the pointer variable. After that, I'm printing out the value which is inside the address. So this will give me the address. This will also give me the address. Both same, because I have already stored the address of this in the pointer variable before. Then using the star pointer, I'm taking out the content from the address. So what will happen is it should print me 5, random hexadecimal, and then 5 again. So let's run the code and see. So if you see over here 5, and this is a random hexadecimal address, this is a random hexadecimal address as well, and this is 5. As you can see, both the addresses same because I have already given the address of whatever normal variable I had to the pointer. The pointer already knows it, but since I'm printing it, both the address will be same only because they're both in the same location. So this way, a pointer can store a memory location of other variable and even fetch out the value from it. So this is extremely important over here. So that is the only thing you have to know currently as a beginner about pointers. Welcome back. In the previous session, we have done pointers and we have understand how pointers work. Moreover, we have seen the implementation of pointers with a program. Today, we are doing the next topic, which is a reference. Now, I will recommend you, if you have not watched the lesson on pointers, do watch it because without that, you will not understand what this reference means. So talking about reference, the concept is very simple. You just have to understand this, that reference is simply just another name for an already existing variable. Simple concept is if you have a variable already, let's say I have int a. I have a variable int a. I will just write another name for the same variable. That is, I will write int b, for example. Now, looking at it, you can say that both of these variables are different, which is absolutely correct. But using reference, I will write another name of the same variable. How? Using the concept of reference. So let's see how does it work. Now think of something like, for example, if you have a variable a, suppose. Now this variable will have a content, let's say it has 5 inside it, and this variable will have a memory location. Now to access this 5 or this location, I need the variable. Fine. This is the original variable. So I'll write original variable over here. Now what I can do is I can make a reference variable for it, reference variable, which will be b over here. And with this b, I can access both of them. Like firstly, I will access the location, then only I will get the value. So you can access the content of a variable through either the original variable or through the reference variable. For example, if I write here in the same example, if I take int a is, let's say, 5. The reference variable, how will I make is I will write int. I will give the and sign like this. I will write the next variable, which is b, which is a reference variable, and I will make it equal to a. This means that currently b is a reference variable to a. Now, one thing here people will get confused about, that it does seems like it is same as pointers. That's why I asked you to watch the lesson on pointers before. They're not actually same. They have a couple of differences. Many people think that a reference and pointers are same, and they're not able to figure out the difference between them because it is acting like the same thing only. Well, there are 3 to 4 major differences. Firstly, when you have a reference, we must initialize it when we create it. Initialization is important. Like if I write here int and a equal to b, as you can see, I am initializing this reference to something. Without initialization, it's not possible. But whereas pointers can be initialized at any time, I can simply write int star x semicolon. That's it. So this is one thing. So this is one difference. Next difference is you cannot have null reference. You can't have null reference. What does it mean? Like there must be a reference connected to some variable. Pointers can be null. Pointers can be null. It's fine. Perfectly fine. But a reference cannot be null. If you are referring to something, there must be something which you are referring to. If you try to understand that in a real life example, if you are referring to something, there must be something you're referring to. So if there is nothing only, then the thing doesn't make any sense. So reference cannot be null. Pointers can be null. Perfectly fine. We don't have any issues with that. But a reference can't be null. That is the second difference. Third difference you can say is that if you initialize a reference to something, then you cannot change it. You can't change that. Can't change. Like for example, let's say a is referring to b. Next time you cannot make a is referring to c. This is not possible when it is the case of reference. But pointers, you can point to any object at any time. There is no problem with that. But a reference, if you have referred to something, it should be that variable only or that object only. You cannot refer to any other object. Like you cannot change the process. So these are 3 major differences between pointers and reference. To understand reference much more better, let's try to see a program of how it works. So here I have a very simple program about reference. And first what I did is I made two normal variables, int a and double b. And next, this is the reference. Here I have used the and sign. V is a reference variable for a, x is a reference variable for b. Then I have given a value 2 to a. Then I'm printing the a. So this will print 2 without any problems. Then for the b, I have given 17.5. So this will also print 17.5. No issues with that. Then we have the value of reference v. Now what I have in v? V has a. That is, it's referring to a. So what it is referring? It's referring that I have v. I have the location of the v, that is with and, but I am only printing the v. So what does v has? V will have the actual value of what a has. Since I have a variable which is referring to another variable, so I also have its location, I also have its value. So when I'm printing the v, I should get the number 2, and I'm printing the x, I should get the number 17.5. So it's just like the same thing, like it's the same concept, it's the same content or the same value, but I'm fetching it through a different variable. So that is what we call as a reference. So if I run the code, this should be the output, that is 2 to 17.5, 17.5. So as you can see, 2 to 17.5 and 17.5. The basic concept here is that I have a variable, I am directly referring to another variable, but with a different name. So that means whatever content that variable has, whether it's its location and the value, will be coming to this variable which is referring to it. And then if I print this variable, I can access those elements also because I'm referring to it. So I already have those values. So I can simply print it out or do any operation with that. So this is the concept of a reference. Welcome back. In the previous class, we have studied about reference and what is a reference and how it works. Today, we are doing an important topic called as class and objects. This is a very important topic when you're making something big in C++, like a very vast kind of project or a bigger kind of project. You have to know what are classes and what are objects. So in very simple words, if I start, what is class? Class, you can generally understand that it's a blueprint. For example, let's say you have to make a house. So before you make a house, we generally make a blueprint, like where will be the floors, what kind of floors, how many rooms will be there, where will be the bedroom, where will be the living room, and all those things. So first we make a blueprint. After that, we make a house. You can say that this is kind of like a prototype. That is, we're making it before we're making the actual model. Similarly, a class is a blueprint which we're making, which will have all the details that we have to fill. Based on that description, we make that particular program. And one more thing, since we have to do class, the word class itself is a keyword. So you have to remember, we can't use it in any variables or something like that. So the name of the word class is keyword. So how do we define or how do we write a class? Very simple way. What we have to do is we have to write the word class first, keyword. Then we write the name of the class. So I'm going to write class name. We start the curly brackets. And here we have to give a semicolon at the end, where we are ending the class. Inside here, you can put any data whatsoever you want. So depending on that, the class will work. With class, always you have to remember that objects will come. Now, what are these objects? So in simple words, objects are anything. What does it mean? For example, car is an object, then let's say a book is an object, pen is an object, anything like that. So when we have to learn about classes, we have to know about objects also. For example, if I write, let's say if I write program can be of different languages, maybe C++, Python, HTML, Ruby, Java, JavaScript. It can be any programming language. Now try to understand here is that this is the class, because we all know that all these are programs. It can be of different languages, but they are programs. And these are all the objects. So of this class, these can be the objects. This way we can understand the relation between a class and an object. If I give you one more example, if I have a car, say if I write car here, the car can be any car, like we have BMW, Audi, Mercedes. It can be any car, but all these have the same like features that all car has, that they move forward, they move backward, they go right, they go left, they have doors. These things are present in every single car, irrespective of which brand they are. They may have some other accessories which other cars may not have, but at least the common thing will be there. So these are the objects and this is the class. So that is the relation. So if I have to show you how you make an object from a class, we first write the name of the class. So class name will come, and then we'll write the name of an object. For here, I'm taking as object 1. So this object is of this class. Now with this object, I can do anything possible. For example, if I have a function, let's say void f, and inside here I have some, let's say r1, r2. Then let's say int main, I have the main function here, and let's say r3, r4. So suppose one function here, if you see, this is one function and this is the main function. Now here I'm creating two objects, 1, 2. And here also inside the main function, I'm creating two objects. Here, this is the class name. This R is the class over here. Now, as you can see, we've created the object in the class in any function of the program. And we've also created the object in the class within the class itself or in other classes also. So we can create as many objects as we want. We just have to have one single class. Now, how do we access it? For example, I want to access this function. So what I'm going to do is over here, I'm going to like in the where we have to access in the main function, I'm going to write, suppose I have to use this object. So I will write R2.
dot f, then I will give a semicolon. I'm just giving an example. So this won't be the object will be different, but I'm just giving an example. So we give the dot, and then that way we can access. So let me show you a program in order to understand this better. So here I have a very simple program of class and object. Firstly, what I did is, as you can see, we have a class, name of the class is room, and then we have something called as public. I'll tell you what is public means. Then we have some variables using all doubles. So when we use, do classes, we have 3 access specifiers. If I write it, access specifiers, what does it mean? Like for example, if I have a class, then maybe another class also, class 2. These two class, this class wants something from this class. So for that, it should access. How can it access? So there are 3 things which are present in one class. We have private members, we have protected members, and we have public members. For now, we'll not discuss the second one. We'll discuss the first one and the last. Public means it is public. It can be accessed by anyone in the class or maybe even outside, depending on how, like, we have certain concept of friend class as well. So with that, they can access. When it is private, then it cannot access. These are private members, which will be accessible only through that particular class only, not by others. So that is the concept. Here in the program, if we have something which is said as public, that means all these things which are inside the public, this entire thing can be accessible without any issues. What we have here, we have 3 variables using double, and then I have made a function here which will calculate the area. What is it giving back? It is giving the length and breadth. So basically it's calculating the area of a particular room. Then the volume is length into breadth into height. It's finding the volume of a particular room, and it's returning back to us. After that, what happens? If you see here, our room 1 over here. So this is the class, and this is the class object name. So here I'm creating the object on this particular line. So this room 1 is the object. This is the name of the class. And with the room 1, that is the object, I can access length, breadth, and height. Or I can provide that also. So what I'm doing, I'm giving the length, I'm giving the breadth, I'm giving the height, and it will go here directly. I don't need any parameters because it's simply a class. Since I have the object, it will be easily accessible. And as you can see, with the same object, I'm accessing the functions as well. So if I run the code, they will all get multiplied depending on you need the area or you need the volume, and they will display it. So let's run the code and see what we get. So as you can see, we're getting the area of the room and we're getting the volume of the room. So it's very simple to understand here is that whatever class I have to create an object. How I create an object? I first write the name of the class, and then I will create any object. Object is something like variable name. Once I have the object, I can access anything from the class. Whatever, like I want to access the variables, or I want to access the functions. So that we can do. Now, if we want, we can also put private members over here in this class itself. Just one thing you have to remember: when things are private, then only it is accessible within the class. Outside, nobody can access it. So that you have to remember. Other than that, the thing are same. Only you can create objects, you can access the members. So that is about class and object. We have done a very basic way to understand it. Welcome back. In the previous class, we have discussed about classes and objects. We have seen the basics about it. Moreover, we have seen the implementation in the program. Today, we are doing something similar to it, a little bit different. We are learning about inheritance. What does this mean is that you can very much relate it to real life when we're talking about inheritance. It's a very important topic. We're going to do object-oriented programming later in a separate part. So it is one important aspect of object-oriented program. What does it do is it will allow you to create a class that is a new class from an existing class. So that means you will have one existing class. From there, you can create a new class. And this is done through inheritance. So let me give you a real life example. Suppose if I have, let's say, animal. Suppose this is a class. If I made another class, let's say cat. Now we know that cat is an animal. So animal, some quality will come in the cat. Am I right? Because animal has so many animals are there in the world. We have cat, elephants, dog, then tiger, lion, everything are there. So some qualities will be similar with the cat. Like if you take in animals only, if you take a lion, tiger, cat, these 3 have some qualities similar to it, because we say lion and tiger as big cats because they are also cat. Their sizes are big. So some qualities, or mostly every quality is same only between them. So from this particular class, which is the existing class, we have created a derived class. How? I have taken some qualities from this class and put it on this class so that I don't have to make it on the new class. That is the concept of inheritance. You will understand inheritance better with a program. So let me show you one program. So over here, I have a very simple program on inheritance. This inheritance, which we are doing right now, it is called as a simple inheritance. There are other types of inheritance also, which we will do in the next session. But right now, we are understanding simple inheritance. What is this? As you can see, I have made a class called as animal. Here, I have made public, fine, and 2 functions are there. I'm just simply printing. One function is eat, one function is sleep. I'm just printing. I can eat, I can sleep. Fine. Now see the important thing. This is important. Here, I have made a class dog. And what I'm doing is I'm accessing the public members of animal. So what are things that are present in the public of animal? This is animal, this is public. These 2 functions are there. So with this class, I'm trying to take the public
elements or the member functions or the functions from animal class. And also inside the class dog, I have a public function which is bark, and it's written I can bark. Now comes the important thing when we're making the objects. See, I have made an object d1 from the class dog. Now see, what I'm doing is using d1. It's fine, the last line is fine because I'm accessing the bark function which is in the class dog, but I'm trying to access eat and sleep, which is not even present in this class, but I'm trying to access them from the animal class. How? Because I have done this. So when you see this thing, this is the main where inheritance is happening. I'm writing a capital I over here. This is called a simple inheritance because I'm taking the member functions which are present in the public of the class animal using the new class, and I'm putting it. Now I can make an object on my new class and I can access those functions using that object. So if I run this code, I should get all the 3 statements as printing out. So let's run the code. Let's see what it gets printed or not. So as you can see, I have access the first 2 lines as well. So it's very simple to understand inheritance, that I have a base class, which is in this case animal. From there, I'm creating a new class and I can access elements whichever I need from the base class. So this is what we call as a simple inheritance. Types of inheritance I will discuss in the next session. Welcome back. In the previous session, we have discussed about what is inheritance. Today, we're going to learn about types of inheritance. So we generally have 5 types of inheritance, which we will discuss. Firstly, we have what we call as a single inheritance. Program that we did in the previous lesson, it was the example of a single inheritance. What does it do is, we have a base class, let's say A, and we do a derived class B. So from one class to another class, if we have a straight line like this, we call it as a single inheritance. Very simple to understand this. Number 2, multiple inheritance. Now, what does multiple inheritance mean is, we have, let's say, a class A and we have a class B. Both of them are creating a class C. So you can say that this is parent and this is the son or daughter. For real life example, you can understand it this way, that this is multiple inheritance. We have 2 base classes. This is base class 1, this is base class 2, and we have a child class. So from the base class, when we derive this way, that is in a parent-son format, you can say that this is a multiple inheritance. Number 3, we call it as multi-level inheritance. Now here what happens is, we have a class A, we have a class B, and we have a class C. Here from A it comes to B, from B it goes to C. So we are not like directly, we are not accessing like single inheritance, we are accessing from 2 classes. So this is the base class. For this base class, this will be the child class. For this child class, this will be the base class. So this way we travel. So this is what we call as a multi-level inheritance, whereas one class is derived from another class and that class again is derived from some other class. So that way we do multi-level inheritance. Number 4 is hierarchical inheritance. Now this is, you can take it from real life only. We have, let's say, one base class. From this, let's say I have derived 2 classes, B and C. Now this B and C will derive 2 more classes, D and E, suppose. And this C will make F and G, suppose. So you can say that more than one class inherits from a single base class. So more than one class is inheriting from a single base class. This is the base class. Here we have a child class. So it's like a tree. You can take an example of a tree. So it's just going down and down and it's increasing. So this is what we call as a hierarchical inheritance. Number 5 will not come into any category, but still we can put it in one category, like it is called as a hybrid inheritance. Now for hybrid inheritance, there is no structure. It is just, you can say that it is like a mixture of all inheritance or one or more inheritance. What does it mean? For example, if I do A, B, C, and D. So as you can see here, this is single inheritance and this is hierarchical inheritance. So 2 inheritance are combined together. We call it as hybrid inheritance. One more example if I have to give you. If I have, let's say, A makes B and C, this B will make D, this C will make F. So this is still here, it is hierarchical. This is single inheritance, this is single inheritance. This whole thing we call it as hybrid inheritance. Very simple to understand. So these are the 5 types of inheritance that are present. I'll name them one more time. First one, we call it as single inheritance. Then we have multiple inheritance, multi-level inheritance, and hierarchical inheritance. Lastly is hybrid inheritance. Welcome back. In the previous class, we have seen what are the types of inheritance, and we have also seen how the types of inheritance helps us in making the program much more simple. Today, we're discussing something different from inheritance. We're discussing a very important topic in C++, which is called as polymorphism. This is a very interesting kind of concept when we talk about polymorphism. Let me give you the idea about the word. So this word is actually a combination of 2 words. If you see here, first word is poly, second word is morphism. Poly means many, And morphism is kind of like a form. So something which has many forms, we call it as polymorphism. Now, what is this and why do we need it in C++? Well, this is a very important concept of object-oriented programming, which you will learn obviously. And it simply means that many forms, as the word gives us the idea about it, simply means many forms. That means in polymorphism, if you have, let's say, one function or any operator, they are same functions. Let's say if I take an example of two functions, f1 and f2, they are same functions, but they behave differently. Then we call it as a concept of polymorphism. So it's the same function, but putting them separately, and both are behaving differently. Why they're behaving differently, even being the same function, that we have to learn. And that is how the concept of polymorphism works. If I have to give you an example, let's say we take an operator. For example, how about we take the operator plus? Now we know that plus, what does it do? It will add things. So if I write, let's say 3 plus 5, we'll get the answer as 8. Fine. Now, if I write like this, let's say if I write Sam Martin, suppose this is a name, and if I put a plus in between here, this will become Sam Martin. So as you can see, same operator is doing two different things. When it is integers, it is adding the numbers. When it's two strings, they are joining the strings, which we call as concatenation, that you have learned previously in the previous lessons. So same plus operator, we are using it in a two different way. We have not changed anything. Operator is same. We have just changed where it is implemented. So here also you can say that polymorphism is occurring in a way, because same thing has many forms. So that means for numbers, it is adding it. For strings, it is connecting it or joining it, concatenating it. Now, to understand polymorphism better, we have to know how polymorphism is applied or how polymorphism is implemented in C++. For that, we have four things. Firstly, when we apply polymorphism, we have to know, first point is, like, you can apply polymorphism using any of these four cases or four types. You can say, first one we call it as function overloading. We'll do individual class on these points. I'm just writing, or I'm just telling you what points we have to learn in the future. So function overloading is the very first one. Second we have is operator overloading. Third, we call it as function overriding. And last one, we call it as a virtual function. So these four types are the ways to implement polymorphism in C++. So we're going to learn, or we're going to discuss each of them individually, and we're going to see programs on them individually as well. Welcome back. In the previous class, we have started learning about polymorphism. Today, we're starting the very first point of implementing polymorphism, which is called as function overloading. The function overloading is also, you can put in the category of compile time polymorphism, which is a type of polymorphism. So compile time. Why it is called compile time? I'll show you that when we learn about the program. But first, let's understand what is function overload. So in C++, what happens is, since it's a function, let's say we have function f1, we have function f2. Think like this, that both functions are of the same name. If I write sum1 and sum1, they are same functions. They don't have any difference. The only difference will be that they will have different parameters. This will have some parameter 1, this will have some parameter 2. So the functions are same, but the parameters are different. That is, it can have different types of parameters. That is int, float, anything it can have, or number of parameters. If these two categories are checked and they are different, both, even though the sums or the function names are same, then we can say that it is function overloading. So how does the concept of function overloading works, we can understand better with a program. So let's check a program first. So over here, as you can see, I have made two functions. Firstly, the first function is sum. Second function is also sum. As I said, same name, but here you can see the parameters are different. First, num1 and num2, you can say that they are same, but the types of parameters are different. This is an integer type, this is a double type. So that is one difference. So as I said, number of parameters may be different, or types of parameters. Here I have implemented both, that is types and even the numbers. So here we have three parameters, even though they are int, but the numbers are different. Here we have only two. Here also we have two, but the types are different. All are simply returning the addition of the parameters that they have. That is the function have. Now what I'm doing is, I'm calling the function over here, that is the sum functions, and I'm passing parameters. So as you can see, the first function I'm calling, I'm passing two parameters, since they have only two parameters. Second one, double, two parameters. Third one, three parameters. That means I should get over here the answer as 11, 12.1 and 18. So if I run the code, let's see what happens. So as you can see, 11, 12.1 and 18. This is the implementation of polymorphism. Here I have overloaded the function sum. Now this is why it is called as compile time polymorphism, is because the compiler knows like which function is to be executed before the program is even compiled. That is the reason
we refer this as a compile time polymorphism, because the compiler already knows it, that which function to execute before we even compile the entire program. So that is the reason it is referred as compile time polymorphism. So this is the concept of function overloading. Welcome back. In the previous class, we have seen function overloading. We have also seen the implementation in the program as well. Today, we're learning about operator overloading. So we can even overload an operator just like as a function, as long as we are overloading user-defined items. For example, let's say any objects, if you want to overload, you can like overload like an operator. You can do that if it is user-defined. That is, we will define. Since objects are made by the user, so we can overload them. Like for example, if you talk about int, double, we can make operators of those data types as well, but we cannot overload them when it is int, double, float, or any kind of like that. But all the user-defined operators, like objects, or you can even talk about structures, we can overload them using certain ways. So if I talk about the concept of function overloading, basically what happens is different operators, functions have the same symbol but different operands. So the symbol will be same. Since I gave the example in polymorphism lesson, the example of plus, this will for int it will add, for string it will join. So that is one example. So depending on the operands, different operator functions are executed, which you will see right now in the program. So let's see a program then of how implementation of function of operator overloading happens. So over here I have a simple program. Here what I did is I made a class name is count, and private variable value, as you can see, for this class only. Then I have a public, which is the constructor, since the same name of the class, so it's a constructor. And inside the constructor, I have a function which I'm passing 5 to it. And then I have a void operator, and inside here, I'm just increasing the value. That is, whatever value I have, the variable which I used, I'm just adding 1 to it. So if, for example, if I'm getting 3 here, it will be 4. Then simply I'm displaying the value. Fine. Then using the class, I created an object C1. And I'm incrementing the C1. Now here what happened is I overloaded the plus operator, which like operates an object of the count class of the count class, that is object C1 in this case. So what exactly we did, we overloaded the plus operator, which will operate this particular object over here, which we have created. And what I did, I simply incremented the object over here. So what it did is actually it directly implemented to the value over here, which I have been using. So since I used this overloaded operator, what it did, it actually directly implement the value variable of the C1 object by 1. Since I have passed 5 to it, it will become 6. And one thing you have to note that this is also called as compile time polymorphism, or it also comes in the category of compile time polymorphism. So simple basic concept is I have just overloaded the plus operator using just one object that I have created. As I told you in the definition that you can only overload user defined types. That is, here I have used objects. So since I've passed 5 here, if I run the code, it should give me as 6. So let's run the code. So as you can see here, it's working perfectly fine. And I'm getting count 6. So that was what operator overloading means. Welcome back. In the previous class, we have learned about what are operator overloading. We have seen the implementation of it. Moreover, we have seen how it works in a program. We're going to the next topic, which is function overriding. Now, this is a very interesting way of implementing polymorphism in a program, is that of how we implement function overriding. If we take an example, let's take an example of inheritance. So when we do inheritance, we do know that we have a parent class, we have a child class. Now the child class, it inherits features from the parent class. Whatever feature it requires, it inherits from them. Suppose that way we have a function, let's name it as f1, and this function is defined both in the child class as well as the parent. Now if we call this function using an object of the derived class or the child class, the function of the derived class will be executed. This is called as function override. The function in the derived class overrides the function present in the parent class or the base class. So the basic thing which is happening over here is the function which is present in the parent class and the child class. If I called using an object this particular function, this function will override the function present in the parent class, and this will be called. Very simple. We'll understand it much more better with a program. So let's see one program for that. So over here I have a program. It's a very simple program where I'm simply doing basic inheritance. What I'm doing is I made a class over here. Class name is base, and inside here I have a function print. I'm simply printing it's a base function. Next I derive using a derived class from the public of base, that is everything this particular function will come, that is it will be inherited. And inside here also I have the same function name, as you can see, same function name, so polymorphism. And here also I have printed one line, which is the derived function. Now what interesting thing here is that what we have did is we have did inside the main function. What we did, we made an object
from the derived class. That is this one. So the D1 is the object of this particular class. Now with this D1, I'm calling the print function. The question is that which print function will be called? Even though I have inherit properties from this particular class and it has the same function. So now it is a little bit of confusion that which class exactly will be called, because that's why only like that print function will be printed. So if I run the code, will I get this as an answer or this as an answer as an output? So basic thing here is that here what happens is, since I have made an object from the derived class, so this derived class object, the print function which is present in the derived class will override the print function which is present in the base class. So that means when I run this code, I should get the derived function and not the base function. That is the concept of function overridden. So if I run the code, I should see on the screen derived function. As you can see, it is showing derived function. So very simple concept. What exactly is happening? Two functions we have, one in the parent, one in the base. Both have same name, so polymorphism is applied over here. When we are creating an object on the derived class, what is happening is the derived class is calling the function which is present on that derived class only. So whatever properties we have inherited from the base class, if the function names are same, that is getting overridden. So only the derived class function is been called and whatever is inside it is getting printed. So very basic concept is just they are getting overridden, simply as it is. So that was the concept of function overridden. Welcome back. In the previous class, we have that what is function overridden. We have seen the implementation in a program as well. Today, we're doing a topic which is somewhat related to a function overridden. We call it as a virtual function. Now, what is this and how does it help in polymorphism? Basic idea is simply that we use a virtual function just because we want to ensure that overridden is met. That means in a program, if there is a confusion of the compiler that whether overridden will happen or not, then we use the concept of virtual function which ensure that overridden will happen. And if overridden happens, that means it's a polymorphism. Now, question is that this generally happens on classes where if we have a pointer based class to an object of a derived class. So if you recall the concept of pointers, this will be applied over here as well. So whenever you see pointers in a program, and if you see this keyword, which is the word virtual, so you will understand that virtual function has been applied over here. So they are forcibly trying to allow overridden to happen just because we want polymorphism in order to act in the program. So for better understanding of virtual function, we have to go through a program. So let's see one program then. So over here, I have a program is using virtual function, and obviously it's pointer based class. Firstly, if you see in the top over here, I've made a class name is base, and inside here I simply have a print function. But if you see very carefully, there's a virtual keyword over here. So that means this function is a virtual function. Fine. What is it doing? It's simply printing the base function as it's a print state. Perfect. Next, what we have is we have a derived class, and we're deriving from the public of the base class. That means whatever is inside this, it will come here. That is, it will be inherited. Same function name, polymorphism, derived function is also here. Fine. Now, the interesting thing or the thing which is you have to know here is in the main function. So what I did, I made an object, and here if you see very carefully, here we have used a concept pointers. Now, since we have declared the void print inside the base class as a virtual function, so this function, which is the print function, will be overridden when we use a pointer base type that points to the derived object. So I have made a pointer which is base 1, and it is going to the address of that object. As you can see, that is G1, and this base 1 is directly pointing it to the print. That means I am now trying to print this particular function, which is over here, so that whatever I have inherited, it gets overridden and we get the derived function as an output. So basically, if I run the code, I should get a derived function as an output, because our main objective is that whatever I have inherited, it gets overridden, because I want this function to run when I'm calling this object. I don't want this function to be called. Both names are same, so polymorphism. But since I want forcibly that this function or this thing should be printed, that means this function should be called, I made a base pointer, that is base 1, which is pointing to the object of D1, and this base 1 is directly pointing it to the print, which is this one. So if I run the code, I should get derived function as an, which you can see over here. The little bit confusing thing is that since we're using a virtual function, we have to use a pointer base class, and here I have made that pointer which is pointing first to the address, and that pointer again, it's pointing to the function directly, which is present on that particular class, and whatever is inside, it's getting printed. So that is the concept of virtual functions.
That was the video for today. If you feel like you learned something from this video, don't forget to hit the like button. Consider subscribing if you want to learn more. Thank you for watching. Bye.